Oh. Hmm. How's life, guys?
You know,
We watched this. What was your Arc Writer account? I don't know. Whatever I logged off yesterday, probably like 7 or something. We are watching. We are going to watch this goddamn HDR video. Okay.
Debunking HDR. My name is Steve.
Jesus. Get ready for the most boring possible video on the planet. I'm ready.
Yedlin. I'm a cinematographer, and the idea behind this demo is to challenge and expand our mental model for how we think about the reproduction of tones, colors, and contrast for motion imaging. And to do that, we're going to have to debunk some common and entrenched but demonstrably false misconceptions about so-called HDR or high dynamic range imaging. But once we unlearn the fallacies and realign our mental model with reality, I think the possibilities are really freeing and empowering, both as image authors and as image viewers. And just to explain what's going on here today, I'm presenting live here at PhotoChem with some guests who are all very accomplished filmmakers, but who also all have very refined eye for the nuances of the photographic rendering of tones and colors and everything. And even before we started the recording, we've been looking at a whole bunch of different images, interiors, exteriors, day, night, bright, dark, contrasty, flat. Some have very nuanced, delicate colors. Some have saturated, vibrant colors. So we've been looking at all these different types of imagery, all completely uncompressed master quality images. And in addition to the computer monitor, we're looking at them on 2 Sony X310s, which are really the top-notch, as good as it gets, color mastering monitors for both HDR and SDR today. They're $20,000 monitors, and these ones are kept in excellent condition and very well calibrated by the team here at Photochem. And I've also checked them myself with a spectrometer before we got going, and they're both excellent. But the thing is that everybody here, I think, agrees that these two images look exactly the same, even though one of these two monitors is receiving a so-called SDR style image and the other one is receiving a so-called HDR style image. They look exactly the same as each other, and they both have the attributes we've kind of been conditioned to think of as being attributes of HDR. There's a lustrousness. We can see these images really clearly and brightly, even though we're not in a darkened color grading room. We're in some subdued lighting with the lights on in the room, and the blacks are rich and deep, but nothing's stopping up in the blacks. It's all smooth and gentle. We can see nuanced colors reproduced really well as more vibrant, garish ones. And the fact that these two monitors look the same, even though one's receiving what would be considered an HDR style signal and the other is receiving a so-called SDR style signal, is the crux of what this demo is about. So to give a little roadmap of where I'm going to go with this is, number one, with regard to hardware, it's beneficial and exciting that technology has advanced and we now have monitors and projectors that can show deeper blacks and brighter whites at the same time in a way that wasn't possible in the past. No caveat there. It's just a boon. It's just a benefit. It's just great that these monitors and projectors are so good. But two, how do we drive these? How are we controlling these monitors? With regard to software or how we control the hardware, we've been bamboozled and we've been conditioned to believe that it requires the so-called HDR formats driving the new hardware to reap the benefits of that hardware. To believe that we need a different unit of measure to numerically quantify the luminance and color coming out of the monitor. But the truth is that to fully mine the benefits, not only is this change in the superficial numbering system not necessary, it's actually detrimental. In its current form, it's creating huge problems while providing little to no benefit. And number three, what do we do? In the short term, we can shed the misconceptions and find workarounds for the problems being caused by the current so-called HDR formats, stop believing that one specific color grading style is enforced by the numbering system, and reclaim the image author's freedom to use any preferred style. In the medium term, we can advocate for using conversion methods between nominal SDR and nominal HDR that are not based on deception and double talk, but on reality. And in the long term, we can get rid of even the need for that by advocating to get rid of the current HDR style formats and the problematic dichotomy that spuriously sets SDR against HDR. And we can advocate for a new replacement format whose specifications are not based on misconceptions or upsell gimmicks, but on how digital imaging systems and the human visual system actually work. And I recognize that if there were to be a new format of this kind in the future, it's got to have some kind of a fancy superlative sounding name, because we all know that high is better than standard and ultra is better than high and super is better than ultra. So we can call this thing whatever it needs to be, super diddly duper vision or whatever. But
can I just say how fucking, what is it? Let's like, fuck, what am I thinking of? There's like two types of 4K, where one is like high def and one is like ultra high def. And it's like, there's high definition, and then one is like 16 by 9, one is 17 by 9, I think. But it's like, why do you have, what is ultra high def? Is it gonna be like giga ultra high def? Is that the next one? Or is it gonna be like super ultra high def? It's just like, so fucking retarded. Yeah, UHD and 4K. Yeah, I think UHD is 2160p basically, and 4K is with a slightly wider aspect ratio.
My hope is to advocate for something where the format itself and not just the name is actually an improvement next time. And just to make some notes for the people who are watching the recorded version of this, you might be wondering, how is it that we can have a demo about HDR that's not in HDR? And when you can only see a screen capture of the computer monitor and you can't see these two X310s? And the answer is twofold. One is that a huge portion of this demo is going to be talking about underlying concepts. And of course, we can talk about concepts and understand them in any DR, the H flavor or the S flavor. But even when we are actually scrutinizing images, as opposed to just talking about concepts, the thing is,
4K, UHD, 2160p are all the same. I don't know if that's true. Let me check. Hold on. What's the one that is, what's the 17 by 9 one called for 4K? Oh, is that called? Is that called true 4K? 4K DCI? Wait, am I thinking 17 by 9 or I'm thinking 16 by 10. I'm adding the number to the wrong thing. I'm fucking retarded. Forget everything I just said.
The recorded
There's a name for the one that's a little bit wider though. Sorry.
version of this, especially if you have a good contemporary monitor and your system set up correctly, actually looks almost exactly like what we're seeing here today. Because as we look at the computer monitor that's here with the two X310s, it looks almost the same. And in fact, the extent to which it doesn't is really just because it's not quite as good of a monitor that can't show quite as deep blacks. And there will be a few points in the demo where the recorded version won't look exactly like what we're seeing here in the room, and I'll point those out. But for the most part, it does. And that actually gets to the very crux of this whole thing. So it's going to take a little while to explain why that is and why it's important. So I hope you'll stick with me through this long demo, but hopefully it's worth it because we can't just replace one oversimplification with another to get at the actual crux. We've got to have to get into some nuances to do that. And, and I meant to say also that for the people watching the recorded version, you can see not just sort of what we're seeing, but almost exactly what we're seeing if you pause here and follow these instructions on screen. And with that, we can dig into these details that we've got to get into to really talk about this stuff. And before we get into HDR itself, there's two foundational topics to discuss. And these two topics are, number one, human perception of tonality and contrast is relative, not absolute. And number two, display color spaces, what they are and how they're interconvertible. So when I say that human perception of tonality and contrast is relative and not absolute, what do I mean by that? So if we have any type of an image at all, or even just an object, the thing that makes it recognizable as being the same to us in terms of tonality is the relative contrast. How much brighter is this chip than this chip than this chip? It's a relationship.
Oh, show the thing.
So that's why if I have this object under a 100-watt light bulb, and this white patch here might be reflecting something like 100 candelas per square meter. But I could then take the same object in the sunlight, and it might be reflecting 10,000 candelas per square meter. But that doesn't make it look like a different object to our eye. Our eyes adapt to the overall luminance, and we recognize it as the same because this one here is always reflecting 66% of this one. And this one's reflecting 40% of that one. And that's the very thing that makes this recognizable as an object, and that's true for everything. This isn't just motion imaging, this is human perception. It's for any kind of object, it's for any kind of image, whether it's a reflective image or an emissive image. Here's the Mona Lisa. This is not a photometrically accurate scan of the Mona Lisas, but there could be a photometrically accurate one, and it wouldn't look that much different than this, so let's just pretend it is. So if we're under a 100-watt light bulb, this little area here is going to reflect a very different amount than if we're in sunlight. But what's going to be the same in both cases is that this one is going to reflect 60% of that. And this area is going to be 7.4% of it. And that's the thing that makes this thing recognizable, because our eye adapts to the overall and actually discounts the overall illuminance and sees the relative contrast. So not only are we capable, not only is our visual system capable of adapting to different overall luminances, you actually can't shut that adaptation off. If we looked at this color chart under a 100-watt light bulb, and this white patch here were reflecting 100 candelas per square meter, and then we took it out under the sun and it was still only reflecting 100 candelas per square meter, it would look like it's a bizarre black hole object that absorbs light. It wouldn't look like the same object. In order to look the same, it actually needs to change and adapt to the overall luminance. And also to look the same, the relative has to stay the same. So the overall actually has to change, not just can change, but has to, whereas the relative stays the same. There's many things that go into visual authorship, obviously. Like in a film, there's production design and shot design and angles and all kinds of stuff. But when we're talking about this limited domain that we're talking about right now of contrast and luminance, then the very thing we're making decisions about is the relative contrast. Where in the shot is something bright and where is it dark, and what's the ratio between them? And these are all frames from things that I've shot where it's a very specific decision.
Is this guy explaining the blue, black, gold, white dress right now? Partly that, but partly also there's a really good optical illusion that all of us have seen. What would I put? Like checkered board, different colors appear same. This one. Oh, we've all seen this one, right? Where this square here, wait, can you see my mouse on this? Yeah. With this square here, the A here is the exact same color as this square here, the B, but it is very hard to accept that when looking at this image. But because of the way the shadow works here, it like kind of fucks our head up or whatever. So this color here is the same as this color down here, but it's very, very, very hard to accept that because of the shadowing. Almost impossible to accept that.
And it goes into every bit of the imaging. We're making decisions about that. So when we're lighting this scene, where we put the light and how bright it is in each area, like this area here is brighter than this area here, and by how much. So we're making very deliberate decisions like that in lighting, making very deliberate decisions about the color transformations we use to take the uninterpreted camera footage and prepare it for the screen. And then we're making decisions again in color grading when we make adjustments. And every one of those decisions is to determine the relative contrast. And if you change the relative contrast, you've changed how the image looks. Like if I were to put this on, that's a slightly different look. And somebody might like this better, but this isn't the look that I was going for when I did this. It's just a different look. But that's the decision process that we make as we decide what we do want it to look like. So relative contrast is the crux of the artistic decisions when it comes to the photographic rendering of tonality. So that's what I mean when I say that human perception of tonality and contrast is relative, not absolute. And then that dovetails into display color spaces, what they are and how they're interconvertible. So I want to talk about how do we actually communicate this relative contrast that an image author has decided on. And the answer is display color spaces. And by the way, I also just want to say this is very intentional that I'm saying display color spaces, because there's different kinds of color spaces. Like there's camera encoding color spaces that are scene referred instead of display referred. There's cylindrical color spaces for doing saturation math on images and such. But in this demo, when I'm saying the word color space, unless I mention otherwise, I'm always talking about a display color space, which is the kind of color space that we use to drive a monitor. So what is a color space? Well, a digital motion image is a series of still frames all in a row, usually 24 frames a second. So you have a series of frames that are made out of pixels, and then each pixel is made out of a triplet, which is 3 numbers. So for example, this area right here, the average of these pixels is 0.505, 0.478, 0.412. So those are numbers. It's not a color and luminance until it's on a monitor. Inside the computer, it's 3 numbers. And what the color space is, it's how we correlate these 3 numbers to what the monitor actually does with physical light in the real world. So really, a color space is a type of unit of measure. Just to make an analogy, this is an image of my living room, because we hear people say, this is what your movie looks like in this color space, and that's what it looks like in that color space. But what I'm here to say is, this is my living room. That's my living room in feet, and that's my living room in meters. Meters, feet. See, the living room doesn't change. What changes is the number that describes the living room. So if the architect who designed this thing did it in feet, and this is 21 feet across, and I'm the builder and I only have tape measures that are in meters, that doesn't mean that I build it 21 meters across, right? Like I have to convert it, and I have to convert it correctly. And if I do that, it comes out exactly the same. If I don't convert between them, or if I convert between them wrong, and the meters one comes out bigger than the feet one, that's still not an attribute of meters versus feet. That's an attribute of my own incompetence for not understanding how to convert between the two. And to an extent, and that is an analogy, but it's such a strong analogy that it's kind of literal, because meters and feet are units of measure, and a color space is a unit of measure. So we have instructions that these numbers, 0.505, 478, 412, are supposed to be this color and brightness. What's supposed to physically come out of the monitor right here when it receives these numbers is 77 candelas per meter squared, which is a unit of luminance we often call nits. And the hard chromaticity, the physical color that color science knows how to measure very accurately what it's going to look like to a human, the physical chromaticity is 0.40, 0.39. So that's interpreting this color space. Now, these numbers are for a color space called Rec 2100. A little bit later, we're going to get into what these color spaces are, but right now I'm just going to say the names and not bother with it. So in Rec 2100, this triplet makes this luminance and this chromaticity. So in the room here, the two X310s look exactly the same, and the monitor up above looks the same. I'm going back and forth between one color space, one unit of measure. See this, here I'm sending 505, 478, 412, and here I'm sending 792, 651. Those are very different numbers, but they look exactly the same because those two totally different sets of numbers correlate to the same chromaticity and luminance in the two different color spaces. And this is barely an analogy. This is just like what happened when I showed my living room in meters, my living room in feet. The image doesn't change, the numbers change. If I convert the image correctly from the one color space to the other, and then if the monitor displays it correctly, they're going to look exactly the same. So that's literally what's happening here, which is, so on the screen, I'm flipping between them, but here in the room, it's constantly happening on the two monitors. To the monitor on the left, I'm sending out the units that are called Rec 2100, and that monitor is in the mode to decode or interpret Rec 2100, and it really is the instructions to build a pixel, just like the architect's instructions to build my living room. And the other monitor is receiving a different unit, a different color space called Rec 1886, and it looks exactly the same because I've done the conversion correctly, because I'm taking the same source image and then I'm preparing one for Rec 1886 and one for Rec 2100. So I've done that correctly, and then the monitor is correctly decoding it. And if they didn't look the same, which is absolutely possible, it would be an attribute of doing something wrong. It wouldn't be an attribute of the color space, because both of these color spaces can perfectly describe 77 nits and this exact chromaticity value. And these are the RGB triplets that go with them. So the two monitors look exactly the same. And both for people watching the recorded version of it, but also here in the room, if you look at the computer monitor, same thing as I go back and forth. Now, instead of it being a monitor that's in the Rec 2100 versus the Rec 1886 mode, it's the viewer process here in my software. So this viewer process knows how this Apple computer's system display, it knows how to talk to it. And this viewer process is expecting Rec 1886 and tells the system display to do the right thing. And this one is expecting Rec 2100. So again, the monitor knows how to build the pixels based on those incoming triplets. So that's the basis of what a color space is. But still, before we get into HDR specifically, I want to get a little more technical about how does it do this? How do we take three numbers and turn them into light on a screen? What is the way? With the meters and feet thing, the way you do it is with a ruler. But how do we know if something is right? How do we know if it's calibrated? And the answer is because humans have created color spaces and these monitors, and they've created them to work together with the same kind of logic. This stuff is actually much simpler than some other things with the human visual system, because probably everyone here has seen spectral sensitivity graphs and all that complicated stuff, which is all very true and it's all very legit, and at the core that applies. But this stuff has sort of already been figured out to make the light out of these blends of the three red, green, and blue colors, which is much simpler. So the way that the color space itself works and the way the monitor works is much simpler than the way light in the human visual system works when you're talking about out in the real world with complex spectral distributions of light interacting with complex reflective spectral distributions of the objects it's falling on. Because when they made these monitors and they made these color spaces, they know how the human eye works, and they were able to simplify it into something that can be defined pretty simply. So a color space is only three things. There's only three things to reliably make these totally different monitors look the same. Those three things are transfer function, primaries, and white point. And we know it works because these two monitors look exactly the same, even though they're set up for two totally different color spaces. We're sending the right code values to each of them for each one's transfer function, primaries, and white point. So what are those things? As we said, in each pixel is a triplet, meaning three numbers. It's just a number from 0 to 1. For red, another number for green, and another number for blue. And the transfer function is saying, based on that number, how much physical light am I going to put out? So the x-axis, the input in this graph, is the code value, the number that's inside the computer file. And the output in the y-axis in this graph is the output, or what the monitor is physically doing in actual physical light energy. So if I send it a 0, it's going to make the minimum that it can physically do plus however it's been calibrated. And if I send it 1, it's going to do the max. But that does not mean that at 0.5 it's going to put out 50% of its light energy. See, at 0.5 it's going to put out about 19%. That's what this transfer function is. And this is the actual transfer function for Rec 1886. It's called 2.4 gamma because this is a 2.4 exponent. So we've got transfer function, and then we've got primaries. What primaries means is when we're saying that we're mixing red, green, and blue, right? The code value plus the transfer function itself tells the monitor physically how bright the red should be, how bright the green should be, how bright the blue should be. But the word red, the word green, and the word blue are ambiguous. There are many different precise colors that get lumped into those 3 broad categories. So the primaries, what the primaries mean for a color space, is what the exact red, green, and blue colors are in hard chromaticity physical light coming out of the monitor. So that's the definition of the primaries. So again, we have transfer function, primaries, and white point. What is white point? Well, when we have these primaries going at the same time in a color space and on a physical monitor, as opposed to out in the real world with like sunlight falling on a scene, you have to make every color out of blending these 3 primaries. You can't make it any different way than that. So the white point means how are these 3 things weighted so that when the triplet is even, like if you're sending it 1, 1, 1, or 0.5, 0.5, 0.5, what color is that? So that's the white point. So see, so if sorry, that's not the white point. I didn't reset this. That's the white point for.
Imagine how disappointed his parents are that he knows so much about this useless topic. Well, considering he worked on Knives Out, and I think a couple of other huge movies he said, I'm probably not very disappointed at all.
This monitor. So as I do this, I'm sending triplets that are equal for red, green, and blue, but just different intensity. And that circle stays the same color, but it's a different luminance going from white to gray and so forth. Now, if there was a different white point, like, let's go a little more extreme, that's a warmer white point. Nobody uses that. I'm just making something up. But it's a different weight of the same primaries. When I made it warm just now, I did not change what color this red is, what color this green is, what color this blue is. I changed how bright they are relative to each other, and I got a different color. So the white point really just tells you how to weight those 3 primaries. And since the primaries themselves are already a weight, because the primaries themselves, what it really tells the monitor to do is how to weight its physical primaries, because the monitor has 3 physical emitters in it that are not going to be the exact same color as the color space's primaries. So the primaries tell it how to weight its hardware primaries, and then the white point tells it how to weight those sort of virtual primaries. But that means that because the white point and the primaries are both weights in terms of actual implementation as opposed to definitionally, they can be collapsed down into one thing. And that one thing is called a 3x3 matrix, which is the mathematical transformation for reweighting a set of 3 things like that. So definitionally, a color space is nothing other than transfer function, primaries, and white point. And then in practice, let's get it back to the real white point. But in practice, it's only 2 things because we can collapse the primaries and the white point into one 3x3 matrix, which is also fairly simple. And this is what a 3x3 matrix looks like. It's called 3x3 because it's 3 rows and 3 columns. It's just 9 numbers. This is just an example. This one happens to be the conversion from Rec 1886 to DCI-P3. So to convert from Rec 1886 primaries and white point to DCI-P3 primaries and white point, all you do is you take the incoming primaries, RGB, you multiply the red by this, the green by that, the blue by that, and you add them together and you get red. And then you do that 2 more times to get green and blue. And it's that simple. So we can perfectly convert, not just sort of, but perfectly, because this is the definition of the color spaces, convert between one color space and another by taking this transfer function off. Because we know exactly what this math is, and we can just do the inverse. This curve is a 2.4 power function, and we know that the inverse is a 1 over 2.4 power function. So when we put the inverse on, they just cancel each other out, and we have a straight line. So you take the transfer function off, you multiply it by the matrix, and then you put
The
the transfer
matrix.
function for the new color space on, and that's it. And it works perfectly. And let me point out that it's not some kind of weird coincidence or alchemy that it works perfectly. It's not some kind of, wow, two totally different things are happening here, but somehow they look exactly the same. That's not at all what's happening. I mean, very simply, these two monitors are physically doing the same thing. What's physically happening is the same because, again, the color space is a unit of measure. So just like the example with my living room, I'm sending the monitor on the left this image described in one unit of measure, one color space, and it's building the pixels correctly. And I'm sending the same exact image but described by a different color space to the other monitor, and it's building the pixels correctly for that color space. So in terms of the physical light output coming out of the monitors, they're doing exactly the same thing. It's not like they're doing two different things, but it just happens to look the same to our eye or something. And that's no coincidence. Because this stuff is published and it is that simple, it's
Wow.
just the transfer function and the matrix. What I'm doing differently in the two types of signal that I'm sending to it, they differ by the transfer function and the matrix. And then what the monitors are doing differently in their processing is the exact inverse matrix and transfer function. So of course they look exactly the same because it's doing the inverse math that I do, and they just cancel each other out and they look exactly the same. So that's not magic, it's not alchemy, it's not something weird. So that's general color spaces. So now we're ready to move on from this. We've talked about display color spaces, what they are and how they're interconvertible. So let's talk about actual HDR color spaces. To do that, let's get into one boring thing before we dig into it is just the names of them, just so you know what I'm talking about when I say them. I've been saying Rec 2100 and Rec 1886 without explaining those. But Rec 1886, its full name, Rec 1886 is kind of a nickname or short name that we use a lot. It's ITUR-BT 1886.
Oh,
and this
yeah, of
is
course.
by far the most used. It's been around for a while, and it's still the most used display color space, used for all kinds of things. We monitor with it on set. We very often use it for final color grading. Consumers get it in Blu-rays. Not all, but almost all streaming, internet stuff, everything. This is still the standard, most commonly used one. It's been around for a while, and it's very solid. There's a reason it was created as a standard. The fact that it's older doesn't mean it's obsolete or not good. So it's the standard SDR style color space, the most commonly used one. And let me just also point out, because you've probably heard this term Rec 709.
Yeah, what's that mean?
When people say Rec 709, they're using a mistaken term to refer to Rec 1886.
Oh.
Rec 709 is a document that's pretty much not used for anything.
Big
and
burn.
it's an encoding color space. It's not a display color space.
He's
It's
calling
not
you
for driving
retarded.
monitors. So I'm not going to be pedantic and correct someone if they say Rec 709, because I know perfectly well
I
what
will
they
from now
mean.
on.
But I'm just telling you why I'm not saying Rec 709, because I have the actual documents here. This is the actual specifications. This is Rec 1886, which is, as I said, it's a decoding color space to drive monitors.
Yeah,
and
right.
Rec 709 is an encoding color space that's not really used for anything at all. And I've been all through this document, and I can promise you that the Rec 709 document does not say anything about how to decode for a monitor, other than it tells you to read the 1886 document. Everything in 709 document, it tells you how to encode, not how to decode. But we don't use that because for camera encoding, we usually use logarithmic encoding. And this Rec 1886 color space is the one that I'm driving the monitor on the right with, and it's the one that I'm using when I'm on this Rec 1886 viewer in the software here on the computer screen and in the recording. And then on the left monitor, and when I'm in this other tab in the recording, we've got Rec 2100. Again, Rec 2100 is the short name. The full name is ITUR-BT 2100, and it's
Okay.
pretty much the only implemented HDR standard, especially when we're talking about what people actually see in a final as opposed to mastering. There are some other codified formats, but this is really the only one that's really implemented. So it's pretty much the basis for all HDR that we're actually using. And this one is also known as SMPTE ST2084. And that's because two different standards bodies have codified the exact same color space. This
Yikes.
is the International Telecommunications Union. And this is the Society of Motion Picture and Television Engineers. And they both codify the exact same thing, so you can call it Rec 2100 or ST2084. And let me just point out that the Rec 2100 document has both camera encoding and monitor decoding specifications in it. But in this demo, whenever I'm talking about Rec 2100, I'm only talking about the monitor decoding part of it, the
Okay.
display color space part of it. Firstly, because the camera encoding part of it is unrelated to our topic here today. And secondly, because it's simply not used. Just like I said, we don't use Rec 709 camera encoding document for camera encoding. We also don't use Rec 2100 for camera encoding. All the manufacturers have their own custom encoding. Arri uses log C, Sony uses S-log, Red uses red log, etc. So it's just not used. So whenever I say Rec 2100, I'm just talking about the display color space part of it. So these are the ones we're going to be talking about the most today, and they're the ones that are most used, and they're the ones that are driving the monitors. But I just want to mention the names of a few others that really are in use today, but not as much. And all of these are SDR style. DCI P3 is used for digital cinema. So on the one hand, whenever you go to digital cinema, it's almost always this color space. But on the other hand, this color space is pretty much not used for anything else. Cool. Display P3 is the color space that Apple computer monitors use. So the monitor itself is display P3, but very often it's receiving Rec 1886 and just converting it to P3, because as we saw, you can convert. Rec 2020 is exactly the same as Rec 1886, but with a wider color gamut. And sRGB is also exactly the same as Rec 1886, but with a slightly different transfer function. And sRGB is what's used a lot of times for like JPEGs on the internet.
For sure.
Stuff like that. Okay, so those are the names. Sorry to have to go through that. So now let's look at what's actually different. Now we're finally getting to it. Sorry, it's been so long. Let's look at what's actually different between an HDR style color space and an SDR one. So I was a little bit cagey earlier about this y-axis here where I was just saying minimum to maximum. But let's get a little more specific. Instead of generic units, let's look at specific units. So what is Rec 1886, the standard so-called SDR color space? The x-axis, this is the code value in an image file. So either the red, green, or blue channel, as we've talked about on a scale of 0 to 1, that's the input. And the output is percentage of the way from black to white of the monitor's physical light output. It doesn't say what black is or what white is. It's just what percentage of the way are you from the one to the other. And as we saw, this makes a lot of sense because that's how the human visual system works. Relative, how much brighter is one thing than another. It's not absolute. And as we saw, in fact, the absolute has to change for it to look the same when the larger environment changes. So this is what Rec 1886 is. So now we're starting to really dig into what's the difference between these things as a format. We know these are great monitors, but we can drive these monitors with either format. A lot of times people are spinning us around. They talk interconvertibly about the hardware versus the quote format, but the quote format is the color space. So when we drive these two things differently, what is the difference between these two color spaces? Well, as I said, a color space is only transfer function primaries and white point, and there's only two differences between the HDR style and the SDR style. So let's look at Rec 2100, which is the HDR one. Now, one thing that's different is the curve shape, because the SDR ones don't necessarily have the same transfer function as each other, but they're all flavors of this similar thing, which is called gamma. So this is a straight gamma one, meaning it's just an exponent. So that this is the output is the input raised to the power of 2.4 for Rec 1886. Some of them have a little straight line portion at the bottom, but all of them are some flavor of a shape like this, of this gamma type curve. All of the SDR ones are, whereas the HDR one is logarithmic instead of exponential. It's actually inverse log. That's what this curve shape is here. It's inverse log, which is even deeper and steeper than the exponential we were looking at before in the gamma style encoding. But the thing is, if bit depths and data rates and all that stuff were infinite and we had no bottlenecks, the curve shape literally wouldn't matter at all, because all you're doing is rejiggering which input number is associated with which output result. So it doesn't matter what the curve shape is as long as you know what the curve shape is. So the curve shape is really only about efficiency. It's not about what the thing can or can't do. It's about how many bits and bytes do you need in your throughput to be able to do what you're trying to do. So the curve shape, we're going to come back to the curve shape. We are going to talk about it later. But for now, for what we're talking about right now, basically the curve shape just doesn't matter at all, because it's only about efficiency, not what the thing is capable of. So the other thing, besides the curve shape that's different between these two, is what the y-axis is. In Rec 1886, the y-axis is percentage of the way from black to white, but it's not telling you what black is or what white is. Whereas when we look at Rec 2100, I'm not even looking at what shape this curve is. I'm looking at what the y-axis is. It's luminance displayed on screen, absolute value given in candelas per meter squared. So one is absolute and one is relative. And by the way, the shape of this curve, this logarithmic curve used in Rec 2100 is called PQ. It's called the PQ curve. So before, when I was talking about this stuff, it seems completely unambiguous how to convert between the two. Take the transfer function off, do the matrix, put the transfer function back on. So you might say, Steve, okay, that makes sense if you're converting one SDR to another SDR or one HDR to another HDR. How can you do that if one of these is absolute and the other one is relative? And the thing is, at first it does sound a little bit ambiguous, but that's partially because of these misconceptions that we've been boiling in. And if you take the misconceptions off, it actually becomes pretty clear how to convert between the two. So there's two base misconceptions. And one has to do with how we quantify how bright so-called SDR is, and the other has to do with how we quantify how bright so-called HDR is. And the misconception with SDR is, and this is very widespread, I see it all the time, people say that SDR is 100 nits. That's absolutely false, because it's HDR, we just saw this, it's HDR that has nits on the y-axis. The units on the Rec 1886 y-axis here are percentages. So you can have any overall luminance for SDR. It's not demanding one or another. It's just saying whatever y it is, when I get the code value 0.8, it should be 59% of that. So it's not absolute, it's relative. So this has become a thing that a lot of people are hitched up on, and I don't know how it ever got there, because if you want to get all technical and correct about it, it's not in the spec. But then also in actual practice, it's not what happens. No consumer has their TV that dim. When I'm monitoring on set, I never have the monitors that dim. There's an industry best practices thing that says in a darkened color grading room, you should have it at 100 nits. But that's not in the color space spec. And also, it's specifically for a darkened color grading room. It's not for a room we're in now with subdued lighting. It's not for being outside in the sunlight. It's not for being inside but with the windows open during the daytime. It's just for a darkened color grading room. And again, it's just a recommendation for the setting. It's not in the color space specification, and it's not what would usually be done in practice. And again, just to say, I have the physical document here for proof. You can look at it too. I've been all through it.
Sir? That's a digital document. What an idiot.
And I can guarantee you in the actual transfer function stuff, white and black are variables. It's whatever they are. And in fact, it explicitly explains how to change them. And not only that, the only time in the entire document that it mentions any absolute value as opposed to relative values is indeed 100 nits. And it's in an example it gives how you might match a digital monitor to an analog monitor that happened to be 100 nits. It's in no way giving that as a prescription. It's giving an example of how you could match those two monitors. That's the misconception about SDR. So the way we quantify how bright the overall luminance of SDR, it's false to say that it's capped at 100 nits. It's purely relative. And then there's also a misconception about how we quantify the overall luminance of HDR. So HDR actually does have, I personally don't think this is a good idea, as you're going to see, but it does have nominal absolute values. So it's not just telling you the relative contrast, it's telling you how bright your monitor is. It's literally prescribing each pixel in your frame is supposed to be a certain physical brightness, no matter whether you're looking at it in the sun or in a darkened room, which right away to me that there's a problem with that anyway, but that's not even what we're talking about right now. So it's got these absolute values, and this convention has arisen where an entire title, an entire movie, is named at a certain luminance based on the brightest single pixel anywhere in the movie, which is not a very good way.
That's wild. How stupid.
To quantify overall luminance. For example, we've been looking at these shots the way that they were intended, basically, because I shot them, and this is my own color transformation for preparing it for the screen with the cinematic color rendering and tonality that I like. So this is how it was intended. But if somebody else wanted to do a different style, because this is what's very much happening these days, is there's these different color grading styles, they could do that. Now, by the way, this is the first time where what you're seeing, if you're seeing the recorded version of this, is going to be kind of different than what we're seeing. What we're seeing when I do this is on the HDR monitor, the window's getting a lot brighter. You know, we still see all the tonality. Nothing's getting clipped or chopped. No differentiation that the camera got is being clamped, but the whole window's getting brighter. On the when I do this, on the SDR monitors, nothing is happening. If you're watching the recording, what you're seeing is you're seeing a sort of subdued version of what we're seeing on the HDR monitor. So you're seeing it get brighter, but we're seeing it much more intense and delineated than in the recording. So to me, these are two different styles, right? This is the style that I actually wanted for the movie, but this is a style that someone else might want. But based on that method of quantifying, they would say this is a 200 nit version of your movie, and that's a 670 nit version of your movie. They're saying this movie is 3.5 times brighter than this movie. That's not a very good way to quantify overall illumination. The overall illumination perceptually is not changing. What's changing is just a style of highlights. It's more like a color grading style than an overall luminance. And I think one of the ones that shows that the best is this shot, because that's 200 nits, that's 670 nits. By that logic, that is 3.5 times brighter than that. Based on what the logic they're using, that's true, because so again, if you're seeing it recorded and you're seeing a subdued version on it, you're not seeing it change by 3.5 times, but we are, and it's still just as silly that sure, this little area here is getting 3.5 times brighter, but again, that's just not a good way to quantify what the overall, again, 200 versus 670. That's not a good way to quantify the overall luminance of the image. It's more a description of the color grading style of the highlights. So how do we quantify the overall luminance of these kind of titles? And the answer to me is we have this concept of middle gray in photography that's been around obviously since way pre-digital.
Yeah, that's what I use.
Atoms and all that, where there's something that feels like it's neutral, like it's middle. And you might not have anything that's actually at that level in the scene, but you're aware of. For example, in this shot, the right side of his face is probably a little brighter than that medium, and the left side of his face is a little darker than it. But there's this sense of where that is. And if a shot feels fairly neutral exposed, you're going to have a lot of pixels around there. If it feels dark, they're going to be under it. If it feels bright, they're going to be over it. And we also have this concept that neutral is 18% gray. So I'm going to introduce a thing. This is my own thing. This is not a technical term that exists out there, but I'm actually hoping that it will now that we're putting it out there with this demo, is what I call scene white. What is scene white? It's my idea of a way to use the concept of 18% gray to help us disentangle the relative contrast from the overall luminance in this so-called HDR system. Because we've never had this problem before. The whole history of visual arts, it's always been that the painter, the photographer, the filmmaker, whoever the image author is, as part of their creative process, they create the relative contrast, and then that never changes. But then the work can be viewed in different situations. With a painting, you can look at it under daylight or under incandescent light. Same with a still photograph. With a traditional film print, if you watch it in a properly set up cinema, it's going to be 48 nits on the movie screen. But if you look at it on a flatbed editor or a moviola or on a light table or in a projection room that's not set up correctly, it's still going to recognizably be the same movie because it has all the same relative contrast, even though the overall luminance has changed. And with the exception of this HDR situation we've got going on, the same is of course true for digital monitors and projectors that have been calibrated correctly. If we're outdoors in daylight or a very bright room, we might want the monitor to be as bright as it can possibly go. If we're in subdued light or a darkened room, we probably want it to be somewhere around 150 nits. And if we're in a movie theater, we want it to be even dimmer than that, because not only is a movie theater completely darkened, not just dim, but completely dark, but also it's much bigger in our field of...
Are you watching this for your monitors or film? Oh, I just don't know anything about HDR. I was just going to know more about this random shit, because why not? We all look at monitors all the time, right?
view, so we actually need it to be even a little bit dimmer to be comfortable. So in a movie theater, we're usually looking at 48 nits, just like on film. But with this HDR system, we've now entangled relative contrast and overall luminance. And in fact, that's the only thing that even makes it HDR, because it's the only actual fundamental difference between SDR and HDR as a format. I'm not talking about the hardware, I'm talking about the format. All the other supposed differences are either superficial or misconceptions and don't actually exist at all. So because HDR has these absolute values instead of relative, when the filmmaker is sitting in the grading room, they're not only authoring their relative contrast as it's always been, but they're also at least supposedly setting the brightness of your TV when you're going to watch it later. So we're going to talk about later how I don't think we should even have a system like this, but while we do, and while it's something we have to navigate, what I'm trying to do is give us some tools to regain the filmmaker's authorship over relative tones and the viewer's ability to view the movie in different situations without messing up those relative tones, both of which have been compromised by a combination of what HDR is definitionally and how we've been conditioned to use it. So what is this idea that 18% gray is neutral? Well, in the real world scene that's being photographed, not the photographic rendering of the scene, but but in the real world, if you have a key light that you're exposed for, and it's lighting a white diffuser, something like a white piece of paper, then however much light that diffuser is reflecting, a neutral gray card or any neutral object would reflect 18% of that. That's in the real world, not in the photographically rendered image. So what is that in the photographically rendered image? Well, in a traditional non-HDR system, that middle gray usually gets mapped to 10%. And since it's a relative system, that just means 10% of whatever the display device is calibrated to. It doesn't have to be a specific amount. Like I said, it could be 48 nits in a theater, it could be 150 nits in a room with subdued lighting, and it could be as bright as the monitor goes if you're in a really bright room. Whatever it's calibrated to, that neutral gray card comes out to 10% of that. And this is pretty standard. For example, my own personal LUT that I use for my color and tonal rendering on my movies, it maps middle gray at just under 10%, and Aries LUT, the manufacturer's off-the-shelf LUT, maps it to just barely above 10%. And the same thing with a photochemical system. For a traditional print system, the Kodak documents that all the labs used for setup have a middle gray card coming out at print density 1.0 above D-min, and 1.0 print density is 10% transmission. So it's going to transmit 10% of however much light is shining through the film. So this is it. This is what scene white is. It's the value that neutral gray is 10% of. So it's 10 times the luminance of neutral gray. So in an SDR system, scene white is simply 100%. So it's 100% of whatever the device is calibrated to. On a film print, the scene white is D-min, meaning the thinnest that the film can be, or the most light that it can transmit. And then in an HDR system, it's a little bit harder to find it, but it's still totally unambiguous. Because the thing is, because the filmmakers are supposedly setting not only the relative contrast, but also your monitor brightness when they're color grading the movie, different movies could have different middle grays. But we now see how to find the middle gray. It's if you shoot an 18% gray card, then wherever that comes out in the HDR system for your movie, then scene white is just that luminance times 10 for your whole movie. This isn't a shot-to-shot thing, this is the whole movie. Because shot-to-shot, if brightness is varied, that's a creative decision. Whereas the overall luminance is an environmental decision. It's where are you going to watch this movie, or what monitor is it on? It's not a shot-to-shot. So scene white in HDR is simply find out where 18% gray comes out, and then it's 10 times that luminance. Now, I'm not saying that you have to have scene white in every shot or even any shot. It's just a construction to understand the overall luminance relative to middle gray. So, you could have a whole movie where nothing even gets up to scene white, or you could have a scene where there are pixels that are way above scene white. Scene white is just a way to quantify the overall luminance in HDR, so we can disentangle it from relative contrast, and that's going to help us overcome these problems that the HDR system is making, where because these things are entangled, we're having problems where the author's relative contrast is getting distorted because it's ambiguous what to do in different viewing settings or when converting between SDR and HDR in either direction. But this is going to help it not be so ambiguous, because now we see how to convert correctly between HDR and SDR. We identify scene white in HDR, and then we can convert either direction and preserve relative contrast from full deep black all the way up to scene white, or maybe just below scene white. And then above scene white, that's the only place where we do something different between HDR and SDR. And that's what I'm doing here on this shot when I do this. See, now the entire image, all of the relative contrast stays the same, all the way up to just below scene white, and then only the very top I'm stretching up and down. So the difference between these two, there's no clamping or flatlining or anything with the highlights. I'm just stretching the contrast of them differently, but only above that cutoff point that's just below scene white. The whole rest of the image, we're perfectly preserving relative contrast. So in HDR, we can punch through this ceiling of scene white, because in SDR, scene white is just 100%, full stop. Whereas in HDR, scene white is 10 times middle gray, which is not a hard and fast ceiling. And also, we see that although most filmmakers authoring HDR today don't have this concept of scene white in their head, and they're not using it or not yet using it for their conversion between SDR and HDR, it's something that's unconsciously happening even if we don't know that it is. Part of the reason I say that it's actually happening, whether we admit it or not, is there's something that I call the iPod shuffle effect, which is you have your music and you put it on shuffle, and a song is really low and you crank the volume up, and then the next one comes on and blasts your ears out. So you would have that problem with HDR, because in HDR, you're nominally allowed to set the viewer's brightness of their monitor. We're going to get into the fact that this isn't actually followed, but if it was actually followed, Nobody would even be allowed to turn their monitor up if it's bright or down if it's dark in the surrounding environment, because these are absolute values. And this is what you're doing in the color grading room. You're setting an absolute level. So you're gonna set a comfortable level for a reasonable viewing environment. And then we don't get the iPod shuffle effect. Like when you watch multiple shows back to back in HDR, it doesn't feel like the brightness of your TV is changing, but only like the color grading style is changing, because we actually have set this scene white whether we admit it or not. And that's got to be in the ballpark of somewhere around 150 to 200 nits, because it actually starts getting painful in a darkened room above that, because we're doing 200 nits here. I think probably 150 is probably a better sort of average, but we're doing 200 today. And, it's totally fine. It's going to start getting painful above this, because don't forget, the white of a cinema screen is supposed to be 14 foot Lamberts, which is 48 nits. That's half of what people think SDR is capped at 100 nits. But I don't know about you, but I've sat in a movie theater, and if it's a dark scene and they do a fade to white, it's painful. It actually hurts. And that's at 48 nits. So if we take this idea of scene white, whenever anybody grades their movie and they're nominally setting the brightness of your monitor that you're going to view it at later, in HDR, which is not what's happening in SDR, clearly they're not going to color grade their movie like in the sunlight or something. So they're going to set it to a comfortable viewing brightness for either a fully darkened color grading environment or maybe something like what we're in right now with a subdued light. And then that means that they're not using all the possible values here. So basically you have to, not just can, but have to have...
Why is this thing empty right here? Are there supposed to be the 3 little battery things in here? Does that mean somebody took them, or... could they spawn in another thing somewhere? It glitched? Oh.
Some sort of artificial ceiling, right? There's sort of the notional ceiling of 10,000 nits, but firstly, absolutely no monitor can do that. None can. There are some special rarefied monitors that do several thousand, but even the most expensive consumer monitors are usually going to be in the high hundreds and certainly under 2,000. But so firstly, you can't even use these high numbers, but more realistically, because of the very fact that this format is setting the brightness on your TV, and they're going to want to set that for some kind of comfortable viewing environment, not for watching it outside in sunlight, there has to be this idea of a scene white, some kind of limited overall illuminance that's not the max of what the format can nominally do of 10,000 nits. So then once we admit that that's what's going on, because it's already what's going on anyway, then we realize that the one thing you can do with HDR, that you can actually do today, we're going to talk about some future ways we could do things, the one thing you can actually do with HDR that you can't do with SDR is punch through that ceiling. Because the ceiling is artificial, you've made it up. Whereas with SDR, the ceiling is 100%, but with HDR, we've made an artificial ceiling because we have to. You can't even not do it. There's no way you're going to put what I'm calling scene white at 10,000 nits, because again, no monitor can do that. But even if you put it at 2,000 nits, it would be uncomfortable at minimum and painful at most. But by setting this artificial limit, by setting it, what it allows you to do is to punch through the ceiling. So now it allows you, if you want to punch through the ceiling. So this gets to what's actually happening, what we're actually looking at here. So I've decided that scene white is 200 nits. You can decide whatever it is. We could have an industry standard, or it could be per project, whatever. But for as long as we have a format that has nominal absolute values, I'm going to talk later about the fact that I think we should...
How are there...
I was literally rounding that corner and I thought you were just gunning at me and it fucking scared the shit out of me. Holy no, dude. Honestly, it was an honest mistake. I just got fucking scared. I'm at extract, you're just gonna leave and just scared the shit out of me.
What the fuck is...
Let me hit you with one of these, good faith. Like, that's my bad. Hold on, man. My bad. Is this guy leaving too?
No, I'm chilling. What the fuck? They're not looting any of these bodies? Oh god, if that guy stays, he's gonna kill me 1,000,000,000,000%.
Anything on these guys?
Well, yeah, they seem pretty loaded. I can't really hold much, but... What, did you guys kill him? I shouldn't have asked you.
I literally just got down here and I was walking towards these bodies, but that guy died with his flashlight on. And then as I was rounding this corner, that guy just jumped right into my face and it scared the fuck out of me. Like if I had my hot mic on when he did it, you would have heard me scream like a little girl.
Well, damn.
Scared the absolute shit out of me.
Jesus, bro, there's like 20 million dead people.
Oh, you don't need the blueprint on this guy?
Nope. There's a deadline on this guy.
A deadline blueprint?
Deadline blueprint, sorry.
Oh.
Fuck, I should have picked up the other. This guy right here's got a lot of shit on him. Oh, my fellow unemployed, or my employed millennial. I should have grabbed all the gun parts too, Jesus. Good luck, buddy.
You can have that. But for as long as we do have one and we're forced into this, we have to admit that there is a scene white somewhere in those absolute values. It's got to be somewhere around between 100 and 200. I think 150 is probably a good one, but again, we're doing 200 here today. So the way that these two things match, the way I was able to perfectly and not just sort of map the one into the other is by deciding that there's a scene white, because you have to set the brightness of the monitor. So I'm personally not doing that punching through the ceiling look that some people really like these days. That's an HDR style look. It's a grading style. It's not a format. It's a style. I'm not a fan of it. So these images, when I'm not doing that, and it just looks like that, my scene white and my peak white are the same. And therefore, these two monitors look exactly the same. Because on the left monitor, I need to set the absolute value in the code values that I'm sending. In the actual triplets that I'm sending to the monitor, I have to set the overall luminance using that, because this is a absolute system. And on the monitor on the right is receiving a type of signal that's relative, not absolute. So the monitor on the right, I have to set the absolute in the monitor. So that monitor is calibrated to 200 nits for SDR. So the one on the left is just calibrated to HDR, and it's getting its 200 nit scene white from the incoming triplets. And the one on the right only gets the relative contrast from the triplets, and the 200 nit scene white is set in the monitor. But on both monitors, we have a 200 nit scene white and the same relative contrast. Now we see the one and only thing that's actually different between HDR and SDR is that you can punch through that ceiling, because in SDR it's a real ceiling and in HDR it's an artificial ceiling, so we're allowed to punch through it. So it's just something that you can do if you like this look. But again, and this is the biggest theme of this whole thing, is we've been conditioned to think this is what your movie looks like in SDR and this is what it looks like in HDR. But that's absolutely false. If you look at the monitor on the left, or for the people watching the recording, I'm currently on the Rec 2100 viewer, this is always HDR in terms of format. The format that is being sent out is HDR. It's Rec 2100. Clearly, Rec 2100 can show this. When it's off, when it's like that, the two monitors here in the room look exactly the same, and when that's on, only the HDR one changes. But when it's off, they both look the same. So clearly, HDR is capable. If you wanted your movie to look like the one on the right, HDR is capable of reproducing that. It doesn't have to distort the author's decision and make it look like that. So you can punch through the ceiling, but that doesn't mean you have to. So yes, this is an advantage, but it's a trade-off. It's not a pure advantage. It's not something that HDR has and SDR just doesn't have anything like that. What's actually happening is, as we discussed, these new monitors are so good, they are so good, that they have more brightness than we actually need, because if we used the monitor's overall luminance instead of doing this, right, because people are using this, like I said, to punch through the ceiling to get dazzly sparkles inside of flames or explosions or glints and things. That's what they're using it for. They're not using it to make the overall picture brighter. You've got that artificial ceiling, so it feels like that's full white, but then you can punch through what feels like full white and get these dazzles. And that's what HDR has. The SDR doesn't. Because these monitors are too bright, you wouldn't want to make the whole image that bright in any normal viewing environment. You wouldn't even want that. So you're using the fact that you're artificially limiting them to punch through. But SDR has a different way that it can use the excess brightness of the new monitors, which is what if you're not in a normal viewing environment? It allows you to adjust to it. And the example that I always think of is at the Tom Bradley terminal at LAX. When you come out of immigration, there's a gigantic monitor showing an advertisement, and it's right under a skylight that's open to the outside. And, obviously whoever paid a lot of money to put their advertisement on there, wants their thing to look dazzling. They don't want it to look dull and dingy. They're paying a bunch of money for this gigantic thing. And I don't know how they actually do that one. I'm just saying, because if they're not following either of these color spaces, that's not an argument for one or the other. But if they were following SDR, then they could have graded it like we always do in a darkened, highly ideal color grading environment, make it as perfect as they can, and then it would translate onto this super bright screen by just following the color space specifications, but for however bright that crazy screen can go. If they used HDR and actually did it correctly, if they didn't do it correctly, there's not an argument for HDR, it's an argument for doing this incorrect thing that they did. If they actually used HDR, then however bright it was when they were supervising the grade, that's how bright it's supposed to be on that monitor, and then it would look dull and dingy. So we saw the one thing that's definitionally different. Well, there's two things, the shape of the curve, which doesn't matter for what we're talking about right now. But the other thing is, the only thing that's definitionally different between HDR and SDR is what these units even mean, what the y-axis even means, relative versus absolute. And then in terms of actual practical application, what does that actually change? And the only difference is HDR has to have an artificial ceiling, and then that means you can punch through it, so you can make dazzly bright things. Whereas SDR, nothing's absolute, so you're allowed to adapt the monitor to the viewing environment. So we keep getting told, this is what your movie looks like in HDR, and that's what it looks like in SDR. But the thing is, again, that's just a grade. HDR is capable of transmitting things that don't have that grade that shows off the one thing that HDR can do that SDR doesn't. There might be pressure from people who make money with upsell gimmicks to grade your movie that way.
But that's an attribute of politics, not an attribute of the format itself.
So like I said, if you're not punching through the ceiling at all, it's completely unambiguous how to convert, as we're doing here. This is why when I show how these movies are supposed to look and without that sizzly highlight look, the two monitors look exactly the same. So it's totally clear if you either started your grade in SDR and you want to convert to HDR, or if you have an HDR look that's a traditional look that has this smooth, gentle shoulder to the highlights, then you can convert perfectly between the two. But even if not, even if you have a movie that does have these sizzly highlight look, you can convert perfectly for every pixel in the entire movie except just those areas. So it's not the overall movie. It's not like the whole movie now has to look different, because as we saw, the thing that makes it what it is the relative contrast. So we don't have to change the relative contrast of every pixel in the movie. We just have to figure out what to do with these sizzly highlights. But again, this is only in the one case. If you're going from SDR to HDR, it's perfect. If you're going from HDR that doesn't have the sizzly highlight look to SDR, it's perfect. And even if you're going from HDR that does have sizzly highlights to SDR, it's perfect, except we just have to figure out what to do with the sizzly highlights. And that answer to me is pretty obvious also. And it's what we're looking at the entire time here on the room on the computer monitor. And it's also what people at home are seeing on the Rec 2100 viewer, which is instead of mapping the HDR scene white to 100% in SDR, map it just a tiny bit below.
And reduce the contrast of those sizzly highlights to fit between the new scene white and the top.
Because again, the key is what makes the image recognizable is the relative contrast. And if you do that, you preserve all the relative contrast in every single pixel in the entire movie, except
Okay,
for
who the fuck understood anything that we just watched? Who knows anything about this? Who? ASOS said it. Okay, this is what I'm getting from this. So the y-axis on your, what do you call these things? Color spaces? The y-axis on the color space on SDR is done in percentages. Your y-axis on an HDR is done in absolute figures and nits. And if you want to have, when he keeps talking about this punching through thing, so it sounds like what he's saying is like, let's assume that we create a film and we film it in 0% to 100%. We film it in SDR, which is that rec. Is it 1880 1886 color space? What did he say? Versus HDR. All of these things at the end of the day, none of this is the thing that the monitor displays. This is the thing that goes to the monitor. The monitor does a calculation to determine what to display. If you, an SDR to HDR conversion works perfectly. So the math on this will always be whatever's recorded in SDR can be shown in HDR perfectly. And then in HDR, assuming your, what did he call it? Your scene white, assuming that you're not going above a certain percentage in that, in terms of trying to get to something to really pop in brightness, assuming you're not going too far above that relatively to what you did on an SDR, something recorded in HDR and then converted onto some SDR graph will also be literally the exact same when it hits the monitor. So the only possible thing that HDR benefits from is because it's using absolute values instead of relative values. You could have the scene white or gray or whatever of some, or scene wipe, or you could have your scene wipe at some percentage. Like in HDR, it might be, what did he say? He said a little bit above or a little below 10%. That you're going to be limited based on that percentage for how bright you could make the brightest part of a scene. Whereas in HDR, you could set that brightness above, 10 times your 10% thing, because you're not a percentage. And that's what he means when he says punching through. However, if you were to take a Rec 2020 thing, an HDR thing, and you were to take down, you were to instead of setting a relative thing from like 0 to 100%, you do it from like 0 to 98%, and then you take the few parts of your color over here that is punching through, that's more than whatever that percentage that would punch through the ordinary 100% or whatever times here that's going higher into the nit range, and you just map that up from 98 to 100%. Anything filmed in HDR would essentially be an SDR thing. The conversion would still work basically perfectly. So it sounds like he keeps saying this is like a color grading thing. It kind of does sound more like a grade rather than like a higher or lower quality thing. And it's not even really, it doesn't even really sound like a dynamic range thing. If I understand what he's saying, I understand why he's making fun of this is standard dynamic range, this is high dynamic range, but not really. If I'm understanding that, I don't know. I'll probably come across this again in the future and I'll hear it again. But
a few sizzly ones, and even they still go up and they look a little sizzly, and they're not clipped or chopped or flatlined or anything. You have all the variation in them. They just don't go up as much as they do on the HDR version. As the people in the room can see, that the computer monitor actually is truly doing the same thing, just not as much, right? Like you can see it poking out in the same way. It just can't go quite as bright because, like I said, we're just moving scene white down a little bit
to make room, and then we're fitting those highlights into that space at the top.
Because, like I said, I just made this version where 200 nits is scene white and 670 nits is peak white.
And that's what we're seeing here in the room on the HDR X310. But on the computer monitor here in the room, 200 nits is scene white, and peak white only goes to a little bit under 300 nits. And that's also what you're seeing if you're watching the recorded version, if you followed those instructions at the beginning carefully.
And I just wanted to say, too, if you don't mind, because I have my hero Roger Deakins here today, Sir Roger Deakins, and I hope you don't mind, I have some shots from one of my personal favorite movies of all time, A Serious Man, which I think is a visual masterpiece, not just in general,
Blazing.
but also specifically for all the tonal and color rendering. All of the decisions made with the lighting on set, exactly where the light is coming from and where it's bright and where it's dark, and then
maybe HDR can be said now have a minimum threshold of what it considers providing a full color experience to a viewer, because now it considers absolute values. Well, but my guess is the TV or something is still probably adjusting these nit values, right? Because there's no way that every single HDR monitor assumes you're in a dark room with all the lights turned off. So my guess is that the monitor itself is probably doing some conversion or something anyway, maybe? I don't know if it has like a light sensor or something, or But also, it has nothing to do with the colors. It would just be the brightness, right? Or yeah, the bright, yeah.
And also all the decisions in color grading. And to me, this is absolutely beautiful. This was before HDR would have been any kind of an option for a distribution. The whites in this movie, which to me are absolutely beautiful, and whole tradition of visual arts with these gentle, beautiful, milky, creamy highlights. And again, it's all about the relative contrast. And the relative contrast is so beautiful.
The final color graded image doesn't have the relative contrast of the scene that was photographed, but instead a very deliberately authored relative contrast.
It's so beautiful how things gently roll into the whites. And none of the whites in this movie are even at 100% in SDR. Like this idea that you have to use the thing just because it has it, they're all down. If somebody said to me, this is Serious Man in SDR, and this is Serious Man in HDR, I would say no, they're both in HDR because the signal we're sending here is an HDR signal. I would say that's a Serious Man, and that's me distorting and ruining a Serious Man. You know, and I'm not disparaging if somebody wants a sizzly highlight look, that's fine. But firstly, don't forget, you can do a sizzly highlight look without actually punching through the ceiling. I don't want to blaspheme Serious Man anymore, so let's look at it on my stuff instead of Serious Man. But if I do this, look at this look. This is a different punchy highlight look. And now here in the room, the HDR and SDR now look the same again with a different, now this is still a punchy highlight look that I don't personally want. But if somebody likes punchy highlight looks, here's one you can do without even going through the ceiling. Because
And when he says without going through the ceiling, it means you could do it on, it's SDR, right?
the other punchy highlight look we were looking at, peak white was going a lot higher than what I call scene white. Whereas now, scene white and peak white are still the same, but you can do a punchy, I'm not claiming this is the same punchy highlight look, it's just a punchy highlight look. So we can see how narrow the application of what you can actually do in HDR is firstly, it's literally, quite literally, just that you can punch through the ceiling if you want that, and not really anything else. But not only do you have to want a sizzly highlight look instead of a more traditionally artful look, but you have to not be satisfied with one like this, and you have to want only that one that actually punches through the ceiling is satisfying to you, because the entire history of visual arts, even before photography, with painting, we've always had beautiful, gentle highlights. You go to a museum and you can look at paintings from totally different eras and different styles, and their whites were already limited because they're reflective, they're not emissive, things not emitting light, and yet you'll see all the time that the white is mixed with grays or other colors to dull it down, because that's the traditional artful tonal rendering. Because you hear people talk about HDR, and this shot is actually an example of what I hear people talk about verbally when they're not looking at a shot. And they'll say something like, oh, well, if you've got a day interior, you've got your actors lit, you can have it actually for real bright out the window. And to me, again, I don't want to enforce a style. If someone else wants the punchy highlights, that's fine. But I'm just talking about sort of the tradition of imaging. And to my taste, that's not an advantage to really sizzle up the highlights, because this traditional way where the highlights have this long shoulder where they keep going, they're not flatlined and clipped,
but they're reducing in contrast. The brighter it gets, the closer those tones are together.
Then your eye knows that it's bright out there, but this is a shot of a person, not a shot of a window. The window is just in the shot behind them. So to me, in storytelling and visual beauty, this is a better way to do it, because it completely gets the sense of it being bright out there.
Those highlights are starting to roll into that beautiful, gentle shoulder. They're not getting clipped or chopped, but they're rolling into that shoulder.
That shows you that it's white and bright out there, but you keep your attention on the person. And the irony is, if you do this, or what if you went farther than this, right? Because this is 670 nits. What if you went to 1,000 or something? The thing is, that's distracting. And B, remember, our eyes do adjust. So if it starts getting really bright out there, the way people talk about it, they'd have you believe, well, he hasn't gotten darker when that got brighter, so he's going to still look just as bright. But that's wrong, because your eye is going to start to adjust to how bright this is. And even without him actually changing, he's going to start looking dim.
And don't forget, if you're watching the recorded version at home, when I punch through the ceiling like this, you're seeing a subdued version of what we're seeing on the HDR monitor here in the room. So how distracting this is, and how likely it is that your eye is going to start to adjust to that window so that the foreground looks darker, is much greater when you see the full version of this than when you're seeing the tamped down version in the recording.
So besides it, to me, just looking sort of caustic, there's that sort of fallacy about it. And like I said, so there's a huge reason not to do it. But again, I don't want to limit artists. Just like I don't want to be limited. I don't want to limit somebody else. So if they like punchy highlights, the two things, again, the one thing to remember is you could do a different punchy highlight look without even punching through the ceiling, which is this one. I know that's not the same look, but that's a different punchy caustic highlight look where we actually haven't brought peak white above scene white. And number two, even if you absolutely demand for your particular movie to punch through the ceiling, it's still not going to change the whole image. It's only going to change where those whites are. So again, sorry that this thing is so long. In a way, we should be done, because we've sort of talked about everything that HDR is, but there's so much misinformation that's ingrained that we need to have a second section on what HDR isn't to talk about the misconceptions and stuff. So welcome to part 2. And as I was saying, if we weren't steeped in all this craziness that's going on, we'd be done because we kind of talked about what it actually is, but let's talk about what it's not, because as we saw, the only definitional difference between HDR and SDR, leaving out efficiency, just what it can do, the only definitional difference is that the y-axis is absolute versus relative on the transfer function.
And then the practical application of that is literally nothing other than to remove the ability to adapt the monitor brightness to the environment in exchange for being able to punch through the ceiling for one specific dazzly highlight look.
It doesn't even do anything with the blacks. You hear people say HDR has better blacks, but it's the monitor that has better blacks, not the signal type. These two monitors are both X310s. They're both good monitors.
So this is interesting too, because the way that HDR has always been described is like you get the deepest blacks, the craziest blacks, but it doesn't really. I guess in effect, maybe that's kind of what you could theoretically get, since the HDR format is telling you where black starts, but technically SDR should be able to have the exact same blacks on a monitor that can display whatever levels. The only difference would be how dazzling or sizzling, he says here, brights are.
Send the number 0 to either one of these, it's going to make the same nice solid black. And if I send the 0 to a crappy monitor, it doesn't matter whether I send it HDR or SDR, it's going to make the same milked out black. When you send 0, it's going to make the darkest black it can make, given both its physical capabilities and how it's been calibrated. So that's what HDR is. But what is HDR not? There's some things that just are things people talk about that are smoke and mirrors that aren't anything. And then there's other things where they are some differences, but they're sort of accidental or implementational or epiphenomenal. They're not fundamental, but all of them,
epiphenomenal, mate,
whether they're the smoke and mirrors variety or whether they're the accidental variety, all of them are, I would say, detrimental or neutral attributes deceptively marketed as benefits. So I would say none of them are benefits. All of them are detrimental or neutral. So we're going to go through each one of these, and let me just read them off before we spend time on each one. First one is inefficient use of data rate marketed as higher data rate. Wider gamut marketed as a benefit when it's not specific to HDR. It's not even a distinction between HDR and SDR at all. And not only that, but it doesn't have the perceptual effect we've been conditioned to believe. A standard that's not standardized doesn't work. Patches that merely fix what's broken are marketed as premium services. Edge cases and outliers marketed as the crux. Loud fallacies and word salads keep us from a reality-based mental model and from questioning marketing gimmicks.
Guy's upset.
Conditioning us to think that the photographic look is dictated by the format rather than by the filmmaker's intent. This is what your movie looks like in SDR, and this is what your movie looks like in HDR. And the irony of loudly boasting that HDR best transmit filmmakers' intent when so-called SDR is the more reliable system for viewers to see relative contrast as authored by the filmmaker.
Jesus.
Okay, so let's go through these. So inefficient use of data rate marketed as a higher data rate. So as promised, I skipped over the curve shape before, the difference between that PQ logarithmic curve that BT2100 uses and the gamma style that Rec 1886 uses. And the reason I skipped over it there is it doesn't change what the thing theoretically could do if data rates were unlimited. It truly wouldn't matter if there was no bottlenecking, no bandwidth limit to the data rate.
It truly wouldn't matter because every chromaticity and luma combination that's in the color space, we can get to it with some input value no matter what the curve shape is. There's nothing we can't get to, so it truly wouldn't matter.
But because that's not the case, because data rate limits are real, it does matter. And let me explain what I mean by that, which is we have limits even from the very beginning, even when we're mastering, when we're in a color grading room and we have the full quality files, we're already not infinite. It's going to get even more bottlenecked by the time the consumer sees it, but we're already not infinite even at the beginning. And a lot of times the calculations inside the computer are maybe 32-bit, the files are somewhere 10 to 16-bit, but what goes out to the monitor is almost always either 8 or 10-bit. And we're talking about driving a monitor. So even if your file is 16 or 32-bit, if what goes out to the monitor is 8-bit, you're still going to get the chunkiness in the actual monitor. And what the bit depths mean is that each channel, red, green, and blue, when you have an uncompressed signal, when you're mastering, we're going to get to when it goes out to the consumer, and it is compressed later. But when you're mastering, if it's 8-bit, that means each channel in each pixel, red, green, and blue, has 8 bits of space for it. So that means there's 2 to the 8th combinations, because it's a 8-bit binary word. So there's 2 to the 8th combinations. That's 256. And if it's 10-bit, that means it's 1024. So that's not extensive, it's intensive. So remember, this x-axis is those code values that are going to the monitor. That is what this is. So if we go from 8-bit to 10-bit, that doesn't mean we change, instead of 0 to 1, we're like, negative 0.1 to 1.1 or something. That's not what it means. It's always 0 to 1. What happens when you go from 8-bit to 10-bit is you know more precisely where along this thing you are. Because when we're in the real world, as opposed to the imaginary infinite world, we don't have arbitrary precision. We can't differentiate between 0.77777777 and 0.77777778. That's too precise. It's too fine. So if it's 8-bit, that means there's 256 fixed steps from 0 to 1. So you can have the number 0, you can have the number 1 over 255, 2 over 255, etc. So there's these fixed steps. And that's as precisely as you can know where along this axis you are. So when you go from 8-bit to 10-bit, this is subdivided into 1024 instead of 256. So you can see, again, forget the curve shape for a second and just think about the units. You can see why the way that HDR works, the idea that this goes from 0 to 10,000 is spectacularly inefficient. Because if they hadn't used this log curve, what if there was no curve, if it was a straight line? If that was the case, let's just put the units on. We know that on every single frame of every movie, basically, most of the pixels are probably going to be 200 nits and below, the broad swath of any movie. So if it's one of my movies, that's 100% of the pixels. And even somebody that really goes crazy with these sizzly highlights, that's still going to be 2% of the pixels in the whole movie or something. So the broad swath of the entire movie is way down here at the bottom, right? Because 200 nits is down here. It's 2% of 10,000 nits. You would be using only the bottom 2% if this was a straight line and not a curve. So your entire image would only have 5 different levels of brightness it could be. So in the real world, inside the computer, these steps are not infinitely small. They have an actual step size to them, a minimum increment. And what we need out of a good imaging system, just like we need pixels to be so small that you can't see them, we need these increments, these gradations of illumination to be so small that they look perceptually completely smooth. So again, if you used this sort of a graph, 0 to 1 for the incoming numbers, and 0 to 10,000 for the outgoing, and your whole image on a movie like mine, where it's 100% of the image is 200 nits and less, you would only have 5 steps from full black to scene white. And let me just show you what that would look like. That would look like that.
Based.
And it's easier to understand why if we just look at one channel at a time, because we're looking at red, green, and blue, obviously, together, because this is a color image. So let's look at just the red channel. And now it still looks just as terrible, but it's clearer what's going on, which is there's only 5 steps from black to white. It can be this amount of luminance or this amount or this amount or this amount, but there aren't any others, right? That's not enough steps. 5 is not enough to look smooth. That doesn't even look kind of smooth. But if we start going up with how many steps there are, if instead of 5, there's 6, 7, 8, 9, 10, it's getting better and better. I'm going to start going up faster and faster. By the time you get to around 40, it still looks terrible, but at least it's starting to look like an image. And by the time you start getting into the hundreds, now it's smooth. Now we have what we're after, which is the increments are fine enough that we can't see them anymore, fine enough that the human eye can't make them out, and it perceptually looks like it's perfectly infinitely smooth,
even though it actually is quantized, even though it actually is made out of steps. So you need a certain number of steps. You need enough steps for it to look smooth. And the traditional gamma curve that we've always used for the entire time there's been digital imaging is fantastic for this. That's why they made it, is because it actually works. The gamma curve combined with the idea that this is percentage. It works great because what this gamma curve is doing is it's reallocating more steps to the bottom end because we're more tuned into the bottom end. Because think about human perception works like when something gets one stop brighter, that's a doubling. It's not the same amount. If I'm inside in a darkened room and I have a candle and I put another candle there,
It perceptually feels like it got a lot brighter.
if I'm outside in the sunlight and I have one candle and I put another candle there, it looks like nothing happened.
Because what feels like an equal increment to us is a doubling or a halving, how much we multiply it by, not a fixed increment, not how much we add by. This has been the theme the
Clear
whole time,
throat.
is that the human visual system is relative more than absolute. So it's not accidental that 18% of scene white, 18%, which we think of in photography as neutral, is stored at 50% in the code value. So you have half of the code values allocated to luminance values above neutral gray, and half of the code values allocated to luminances below neutral gray.
And it works really, really well. So the shape of this curve combined with the y-axis actually working like the human visual system as a percentage works great. That's why they came up with it. Now I don't know why they came up with this. To me, this is a huge problem. This y-axis is a huge problem for any kind of reasonable efficiency. Now the PQ curve itself, I have no complaints with it. It's probably the absolute best solution they could have come up with. I don't know who came up with this PQ curve, but it's the best solution they could have come up with given that these are what the axes are. But the fact that this is what the axes are is a spectacular problem in itself, because you can see what they did. It would have been an absolute unusable disaster if it was a straight line, right? If they would have used a gamma curve, it probably would have helped, but not enough. So they went even deeper with this reallocating those steps towards the bottom. So you can see now, if this was a line instead of a curve, there would only be 5 steps for everything up to 200 nits, which is around here. 5 steps if it was 8-bit. But now instead of there only being 2% of however many steps there are, there's like 65%. And so from black to scene white, some kind of a reasonable scene white anyway, we're now using 65% instead of 2%. So great, that's really smart that they did that, but you're still only using 65% instead of 100%. So because presumably anyway, in SDR, scene white and peak white are the same thing, whereas here they're two different things. Everything up to scene white's only using something like 65% of however many steps are available. If it's 8-bit, it's 256. If it's 10-bit, it's 1024. But it doesn't matter it doesn't matter whether there's 5 of them or 5 million of them. However many of them there are, HDR is only...
Wait, am I not getting credit per deliverable? Wait, what the fuck? I thought I delivered 3 things. Wait, what's happening?
using 65% of them up to scene white. Again, 100% of my image and 95% of the image of movies that have that punchy highlight look.
It's
So
a
the
bug if you
rest
take
is
it to the
wasted
same
by
spot.
holding out all this space for pixels that don't exist anywhere in the movie.
And we can see that. I actually made a chart here. You have these single code values, right? You can't go up in a smaller increment than a single code value. In 8-bit, that's 1 over 255, and 10-bit is 1 out of 1023. So here's a chart of how much does the luminance change when you go up the smallest increment you can possibly go up, which is 1 code value. And to be able to do a comparison like that, you do have to pick a scene white. If we picked a different scene white, these numbers would be a little different, but it wouldn't change the magnitude.
But this is for 200 nits. This is for when your scene white in both the 1886 and the 2100 monitor is 200 nits, as these two X310s are here today.
So if they were both 8-bit, down at the bottom, it's fine. Because remember, a single increment is going to be a different amount depending on how bright it starts, because that is a curve and not a straight line. And PQ is the only reason. I'm not complaining about the PQ curve, I'm complaining about the y-axis. So PQ made it as good as it can be, but it can't overcome how much of a bad idea this is. So at the bottom, you're fine. If I'm at 0 and I go up 1 code value in 8-bit, the SDR is going to go up 0.0003 nits, and the HDR is going to go up 0.0004 nits. Well, certainly that's fine. That's not too coarse of a step. That's a microscopic step. That's fine. That's going to look smooth to humans. But you can see already by the time we get to around middle gray, the smallest increment that HDR can do
is over double the smallest increment that SDR can do.
Not surprising, because we saw it's only using 65% of the code values.
And by the time we get up to scene white,
The increment is almost 4 times the SDR step size.
so when they say HDR is 10-bit and SDR is 8-bit, what it means is HDR needs 10 bits. It's a trick. It would be like if I said,
This whole section is him arguing how the transfer function for HDR is inefficient. Yeah, sure. So what he's saying is that, he's about to make the argument, right? Is saying that there's a higher bit rate, or that HDR is 10-bit versus SDR is 8-bit. Therefore, HDR has greater space for displaying shit or whatever. The reality is because of the what would you call that, the gamma curve, because of how fucked the steps are when it comes to doing the brightness for HDR. You need the 2 additional, what would you call it, magnitude. You need the 10-bit versus the 8-bit in order to even have like an unnoticeable difference in brightness, or to have the appropriate link between steps in order to do that or whatever, right? Jesus Christ, that wasn't the best explanation, but
isn't $12 better than 10? And you said yes. I said, then okay, give me $12.
Bit depth is the coin you pay in with, not what you receive. You use up your limited bandwidth, your limited data rate, to get a good image. So you don't want to squander that limited.
oh damn, this guy's got stuff on him. I don't think I can carry much. Yeah, here he's got like a bunch of flame grenades and stuff. I don't know. Did you check this guy? I could kill both these motherfuckers right now.
Thanks. This sounds done.
Okay, call it whenever, yeah. Damn, how you guys just gonna hate on the... Damn.
Thank you.
Jeez. Wonder how those guys died. Rip.
Resource, you want to use it well. HDR needs you to pay 10 bits for it to be only as good as SDR is when you only pay in 8 bits.
So if the HDR goes up to 10-bit and the SDR doesn't, look what happens. Now HDR has finer increments all the way until we get to close to scene white, then they converge again. So if we want HDR to be just as good in terms of how fine the increments are, from black to scene white, the whole range, not just part of it, if we want it to be as good as SDR, we need 10 bits because they're literally converging here.
If it were 9 bits, the HDR would again have a coarser increment here at scene white.
The thing is, there's nowhere in the spec that says you're not allowed to put an SDR
Oh, you could just do SDR at 10 bits.
image file into 10 bits or a HDR file into
Into
8
8 or
bits.
whatever.
There isn't. You can put anything in any container. So the reality is the reason that HDR is 10 bits is because it needs 10 bits to look as good as SDR's 8 bits. So just now we were comparing what if the one goes up but not the other, but let's compare apples to apples again. If the SDR also goes up, then of course it's just better again by the same exact factor that it was when they were the same before. Now at 200 nits, 10-bit SDR only goes up by half a nit, whereas HDR goes up by almost 2 nits. And the other thing that you can see here is how absolutely absurd the numbers at the top of the chart are, because even at 10-bit, the smallest increment you can do if you're at 10,000 nits and go down 1 is 94 nits. But we need these fine increments for things to look smooth, for gradients to look smooth both in time and in space. Like if you do a fade, that needs to look smooth. If the increments are too coarse, it's going to look choppy or stuttery. And the same thing if you have a gradient in space as opposed to in time. Like if you have a smooth, even, like a flat wall that's lit from one side, or if you have a kind of bland sky that's brighter on one side than the other, you're going to have a smooth gradient. You're going to see the steps. And this is a very real thing. This is not some kind of notional, hypothetical, intangible thing. And I'd like to show it to you. Okay, so we're still, remember from before, we were still looking at just one channel at a time so we can see this better. So we're looking at the red channel. I'm going to go to that fire shot. Now I'm going to put the quantization to 256, which is how many steps we have in 8-bit. And so, by the way, what's going on here today is I'm sending out to both of these X310s 10-bit.
And for the computer monitor,
Nuke itself is 32-bit, so we're limited only by the negotiation Nuke has to do with the system display, which I know for sure is at least 10-bit, if not higher. I don't know what it actually is. Now, of course, if you're watching the recording version of this, you might see compression artifacts from the fact that you're watching this streaming or something. But we're looking at the computer monitor uncompressed, even if you're not when you're watching the recording. So everything right now is 10-bit or higher going to the monitors. And both of these, I'll go back and forth for the people watching the recording, both of these look totally smooth. We can see all the gradients that the camera got. You're not seeing banding or whatever. But what I'm going to do now is I'm going to chunk it to 8-bit, meaning the precision is not any better than 8-bit. Again, that's precision, not expanse. We're just going to show it with less precision so that there can only be 256 steps from black to white. And do you see how bad that is? That's the HDR. I'm going to zoom in on it a little bit.
Not
I
good.
mean, it's actually terrible. We've
It's
lost
atrocious.
the illusion of a smooth gradient, and you can very clearly see
Unbelievable.
the individual increments,
Wow.
the smallest steps that can be made
Disgusting.
when it's 8-bit. So here in the room, we're seeing that on the left and on the top, but
Now doing it SDR and show them how better it is.
we're not seeing it in SDR. And I'm going to go to SDR on the computer screen. So the
Wow. The SDR is better at 8-bit.
SDR is totally smooth at 8-bit, and the HDR isn't.
Oh, I'm cringing right now. My God.
now if you're watching the recording version of this, it's probably pretty compressed for the web.
Doesn't
so you
matter.
Might be seeing
We still
a
see it
little bit
better.
of compression artifacts, and it may not be as completely perfectly smooth as it is here in the room. But even if so, you should still be able to see quite an improvement
Oh,
in how
we
much
do.
more efficient SDR is at using the bit depth than
Unbelievable.
So this is a very real thing. When they
Yeah,
say
we're laughing
it's
too.
10-bit, they mean it needs 10 bits. It's a data hog is what it means. So that means at any data rate, if it's an apples to apples comparison, it isn't a comparison where HDR gets a handicap where it gets 10 bits and SDR gets 8 bits. Any apples to apples comparison at a given data rate, the SDR curve is going to be better because of what we saw.
You're using 100% of the steps from black to scene white instead of using something like 65%.
And I also just want to point out that this is also very real application in the real world. We're not living in some kind of future times where efficiency doesn't matter because our data rates are so gigantic that who cares? Because first of all, literally even in a completely professional environment where we have all the expensive professional gear, forget even before it gets to the consumer.
Even then, it's only sometimes 10-bit. We still often look at 8-bit.
So the problems already starts when we have expensive professional stuff. And guess what? It's going to get a lot worse by the time the consumer sees it. Because again, we're not in some kind of future world where data rates are unlimited. So I just want to show some actual data rates. Now, when it's uncompressed, when you have a fully uncompressed image, which is as good as it gets, meaning there's no image compression on it. When that's the case, it's completely unambiguous how much bandwidth you need, what the data rate is. It's not at all variable. So if you can have different image sizes. This is the HD size, 1920 by 1080. So it's unambiguous that there's 1,920 pixels across by 1,080 high. If it's 8-bit, it's 8 bits per channel. There's 3 channels, red, green, and blue, 24 frames a second. So you got to multiply all those together. That's 1.2 million bits per second, or 1,200 megabit. Okay, let's look at some different sizes. So that same thing. So what if it's 10-bit instead of 8-bit? That's almost 1,500. What if it's 4K 8-bit? That's almost 5,000. And if it's 4K and 10-bit, that's almost 6,000 megabits. So even DCPs, which look really good, that's what we send to the cinemas, even those that look really good, they're actually pretty compressed. And what image compression means basically is you're just throwing information away and hoping people can't see it. So this is a very real bottleneck, right? So you're already compressing from a couple thousand to several hundred, even for DCPs that look pretty darn good. But when people watch stuff streaming at home, if you pay the extra to get the higher tier and you have the fastest internet connection, then you're going to get 19 megabit. So the thing is, this is not enforced out of nature. It's just what they actually do. They don't offer 19 megabit at 2K SDR, which would be less compression and actually look better. When the bit rate goes up,
They also put it in a less efficient container, so you immediately lose back some of what you just gained.
but remember, HDR is also the case with 4K, but HDR is a data hog. As we saw, you've got a fixed container. You can't up the container because these aren't just limited by your personal
Uh-oh, Dan linked a debunking. A debunking blog? What? Steve Yedlin's technical assertions warrant scrutiny. When it comes to formats, i.e. color space, as opposed to hardware, with the exception of one thing, which is a trade-off by advantage, things are what acclaimed cinematographer Steve Yedlin declared HDR's advantages, detriments dressed up by misinformation at a closed-door photochem presentation attended by industry luminaries such as Roger Deakins, Netflix's Joseph McCormick, and leading color scientists. He ignited a powder keg in imaging circles. His arguments demand rigorous examination. We unpack the claims, evidence, and critical omissions in the conversation. Cinematographer spoke for 2 hours to a receptive group of devotees at Photochem, endlessly repeating himself and introducing questionable terminology like punching through the ceiling to describe HDR highlights, ensuring that we'll be hearing this problematic phrase ad nauseum from his legion of fans who used to go, oh my god, this guy's mad as fuck. His skeptical tone and dismissive demeanor, his inaccurate framing of BT 2020 as a mastering color space rather than industry standard P3D65, claiming that HDR is a grading style only that has no aesthetic value. Oh, this guy's either fucking retarded or this entire conversation is completely and totally beyond me. Is this guy a cinematographer or is this guy just a random no-name blogger? Because this guy either didn't understand anything that's been said. I picked up the answers to these questions while playing Ark, or this conversation is beyond me. His skeptical tone and dismissive demeanor, his inaccurate framing of BT 2020 as a mastering color space rather than the industry standard P3D65. I'm guessing P3D65 is an actual color space. When he's calling it a color space, he's joking or he's being dismissive. It sounds like it's, from what I'm picking up, the guy in the video we're watching, what's his name? Yedlin, is basically saying that like this is a question of basically color grading. You're not gaining some absolute advantage in dynamic contrast. There's not an absolute like guaranteed advantage here. Like some of this is arguably just stylistic in terms of what you're able to do. Claiming that HDR is a grading style only that has no aesthetic value worth pursuing. Well, it sounds like he's saying theoretically, depending on how you do your SDR, you theoretically could get anything you want in terms of how it's ultimately displayed on the monitor anyway, arguing that SDR in an HDR container is still HDR. Well, there might be a reason. Maybe there are reasons for this. Maybe he'll get into it. I don't know. Wait. The following is the final... Wait, where'd you get this from? Hold on. Summary of Yedlin's presentation available for download. The following is the final paragraph from a ChatGPT summary of Steve Yedlin's debunking HDR presentation created by Adam Ring from a transcript. Rain is breaking it down into sections and added key takeaways. I don't even know what that means. Or why you would even cite it here? I don't know. Never mind. I don't know. Okay, hold on. Let's dig through some of this, I guess. Since Yedlin so casually distorts the truth, contending that HDR is no more than a grading style, let's not overlook present-day SDR practice. Few things are more objectionable than flat lighting, low contrast grading, detail destroying diffusion filters, piling on heaps of fake grain, premature highlight roll-off, and lifted shadows, all in a misguided attempt to emulate an imaginary dated analog film look. The HDR is an end-to-end process from capture and post-production to storage, distribution, and display. In order to be successful, the color contrast and highlight and shadow detail, as well as the compositional choices that make effective use of HDR, need to be evaluated on set, thereby ensuring that the look... it's either beyond me or this guy's fucking retarded. I can't tell. I don't know. So who knows? I don't know.
ISP, if you pay to get really fast ISP, that's not going to speed this up. It's not going to give you a better data rate, because Netflix and all the other streamers, they have to have a server that can send this stuff to millions of people at a time.
And that's why you're never going to get more than 19 megabits out of it, no matter how fast your own connection is. And they don't even give you the option to see 2K SDR compressed to 19 megabits, which would be a more efficient use of the limited container.
As we saw, HDR is a wasteful use of the container. You're based.
Did he not explain that? That's the Blu-ray version? Well, no. What it sounds like, if I'm understanding both of these, and I don't know much about coloring, I don't even color grade anything. I don't even know how to do color grading. Fuck all that bullshit. But it sounds like the author of this blog is falling into the trap that that Yedlin made this video explicitly to criticize. That people will look at a film, or people will look at it and go like, oh, HDR? HDR is going to mean it's going to have better color, it's going to have better contrast and highlight and shadow detail. It's going to have like the compositional choices to utilize HDR. These are going to be all. And what Yedlin would say is, no, this is all part of like basic cinematography. This is all part of like having a nice looking film. This can be done in SDR, HDR. Doesn't have to, just because you make something HDR, it doesn't guarantee that any of that stuff is going to look nice. And all of that stuff can look just as nice in SDR. You don't have to evaluate any of this stuff. Is basically what he's. Is what Yedlin's argument is. But this guy is like, no, you need the 10-bit HDR camera, and then you need the HDR thing, and then you need the HDR cable, and then you need the HDR monster can, and then it's going to be HDR, and everything's going to look HDR and way better, is what it sounds like. One point during the presentation, Yedlin remarked how difficult it was to make out the face in a shot after brightening up the window in the room, which is ludicrous because, one, a bright face against a bright window looks inauthentic, and two, some of those powerful moments in narrative HDR, narrative HDR, are when a character's face is intentionally obscured or silhouetted. Wait, actually, I'm not convinced that this is even written by a real person. Wait, who is the author to this? The Dejan Chronicles. Who is this person? This is like the ultimate. This is the ultimate Dick Rider HDR blog. Wait, what the fuck? Kelly's creative potential of HDR. DaVinci Resolve certified trainer spreads disinformation. In an article unironically titled, Don't Repeat These Mistakes About Color Space in HDR, Insights from the Demo, Debunking HDR by Steve Yedlin. Daniel Bonielos Couillard, a lead editor and post-production supervisor specialized in HDR workflows, shared some takeaways after watching Yedlin's presentation. We unpacked just a few of the, myths of the incorrect, a few of the outrageous claims and glaring inaccuracies. Quote, extreme brightness does not necessarily improve the image, end quote. There is nothing extreme about a well-graded show with carefully deployed 1,000 nit highlights. The major studios don't dictate the peak brightness level of films anyhow. When we talk about HDR, what we do use is Rec 2100. No, we do not. Netflix, Disney, Apple mandate P3D65, ST2084. The visual anchoring is key to understand why some HDR systems end up looking weird or crushed. No, it isn't. If a grade looks crushed, it's the fault of the colorist, not biology. The eye doesn't see an absolute nits, nor should it. The claim, PQ's absolute values are unnatural because vision is relative. The reality, PQ ST2084 is designed to honor human vision by reproducing the actual luminance levels, absolute nits, found in the real world, rather than relying on the relative percentage-based approach used in SDR. Sick. Sick. He's so mad. Oh, damn. Okay. What if we were to accept Yedlin's framing? Is the world going to fall apart? Fact check! Rec 2020 is exact same as Rec 1886 with a wider color gamut. Fact check! This statement is categorically false. Rec 2020 isn't a minor variant of Rec 709. It's the comprehensive standard for UHD TV. Imagine using color gamut, narrow, 2 inches, thin, versus Rec 2020, UHD TV, color gamut, wide, 17 inches, thick, girthy, veiny, throbbing. Okay.
Basically taking a fixed container and you're holding out all this space in it for stuff that's not used. Imagine like you're packing your suitcase to go on a trip and you're only allowed to use a third of it. So you're holding out all this space for these like 10,000 nit pixels that don't exist in your movie at all, 4,000, 5,000, 10,000, etc. So they're only offering the more inefficient thing at 19 megabits. So it's already a compromise.
This is 314 times compressed.
If they're sending you 4K, and then HDR needs to be 10-bit, not 8-bit, then that's almost 6,000 megabit, but they're sending it to you at 19 megabit. So we have these unbelievable bottlenecks. So any kind of sense that, hey, it doesn't matter whether it's efficient or not because we live in some future world where efficiency doesn't matter is crazy. I'm not saying the streamers look terrible. They actually look pretty darn good, but they don't look as good as they could. If I take my movie and I take these uncompressed frames we've been looking at and I compress it the exact same encoder settings that they use for the streamers and I put it to 7.5 megabit or 12 megabit or 19 megabit, I see macro blocking that's much bigger than a 2K pixel, let alone a 4K pixel. And I see visible blurring and irresoluteness.
Compared to the original uncompressed version that I've got right next to it.
The image is clearly getting worse. It's not just sort of hypothetically getting worse, but you can't see that it is or something. It's not just mathematical, but not perceptual. It's perceptually getting worse. So the idea that we want inefficient systems is crazy. We're nowhere near. It's not even on the horizon where it's, a couple years away that normal people would be streaming even 250 megabit, let alone 6,000 megabit. So efficiency does matter today very much. And for any foreseeable future, maybe we'll have some discontinuous technology change as opposed to a slow ramp that I don't know about. But for the foreseeable future, we can't just be willy-nilly inefficient because it actually in real life makes images worse. So that is inefficient data rate marketed as higher data rate. HDR is 10-bit, it's better. No, it's worse because it needs 10 bits to look just as good, and we've got bottlenecks all through the system. Okay, wider gamut marketed as a benefit when it's not specific to HDR and doesn't have the perceptual effect we're conditioned to believe. So that's kind of two things. So the one is, you hear it boasted about that HDR is a wider gamut, but that is not at all a differentiation between HDR and SDR. As we talked about, every color space has its definition of its primaries, and the gamut is just whatever those primaries are. So I'm sure everybody here has seen this before. Maybe some people have a clearer understanding than others as to what this thing means. This is called the CIE hull, and it's a map of all the different chromaticities recognized by humans.
So it's the hue and saturation without the luminance.
Wait, I can see these though. Holy shit! Am I a god? I can see these outside the triangle. Oh, you guys just see the colors in the triangle. I see the colors outside the triangle. How mad are you guys?
Getting worse. So the idea that we want inefficient systems is crazy. We're nowhere near. It's not even on the horizon where it's, a couple years away that normal people would be streaming even 250 megabit, let alone 6,000 megabit. So efficiency does matter today very much. And for any foreseeable future, maybe we'll have some discontinuous technology change as opposed to a slow ramp that I don't know about. But for the foreseeable future, we can't just be willy-nilly inefficient because it actually in real life makes images worse. So that is inefficient data rate marketed as higher data rate. HDR is 10-bit, it's better. No, it's worse because it needs 10 bits to look just as good, and we've got bottlenecks all through the system. Okay, wider gamut marketed as a benefit when it's not specific to HDR and doesn't have the perceptual effect we're conditioned to believe. So that's kind of two things. So the one is, you hear it boasted about that HDR is a wider gamut, but that is not at all a differentiation between HDR and SDR. As we talked about, every color space has its definition of its primaries, and the gamut is just whatever those primaries are.
So I'm sure everybody here has seen this before. Maybe some people have a clearer understanding than others as to what this thing means. This is called the CIE hull, and it's a map of all the different chromaticities recognized by humans. So it's the hue and saturation without the luminance, so it's just color. And when you're looking at a scene in real life as opposed to on a monitor, there's many different combinations of photons can make the same color. Like there could be one blend of photons that looks exactly the same to our eye as another blend of photons.
What?
And those will be at the same position on this map because they're the same color. But when you're making colors with the monitor, there's only one blend that'll make any specific color
because the monitor is just a blend of 3 illuminants.
So for a given color space, we've defined
what those primaries are, right? In 1886, they're the corners of this triangle.
If you turn the blue on, if your triplet, that triplet that's going out to the monitor is 001 for blue on and the other two off, you're going to be here. And if you crossfade from blue to green, you're going to go along this line to here, green to red there, and then red to blue there. But then if you start crossfading all 3 of them, if they're all up, you can make any color inside of here. That's what we were talking about, was with the exception of edge cases, the color spaces are interconvertible because you can make any color that's in the gamut. If you do the conversion right, it'll build the pixel right and you'll make the same color. So this is the Rec 1886 primaries, and those are the primaries that they boast are wider primaries for HDR that are in the Rec 2100 document. But guess where the Rec 2100 document gets them? It says, hey, use the primaries from Rec 2020, which is SDR color space.
Whoa, shit. What?
When you're looking at a scene in real life as opposed to on a monitor, there's many different combinations of photons can make the same. Turn the blue on, if your triplet, that triplet that's any color that's in the gamut, if you do the conversion right, it'll build the pixel right and you'll make the same color. So this is the Rec 1886 primaries, and those are the primaries that they boast are wider primaries for HDR that are in the Rec 2100 document. But guess where the Rec 2100 document gets them? It says, hey, use the primaries from Rec 2020, which is SDR color space. Of course you can have these primaries and have SDR because the primaries are just the primaries. If you say they're here, here, and here, instead of here, here, and here, then they are. That doesn't mean that you need the y-axis of the transfer function to go from 0 to 10,000 nits instead of being relative. It's just 2 separate things. So it's true that Rec 2020, although it's a codified color space that has its own one of these documents, and we use it for the primaries for Rec 2100 and all that, it's true that it's not really implemented, like we're not really using it for anything. But the thing is, it exists, it's codified. So not only hypothetically, but even already implemented, SDR, of course, you can just say the primaries are wider and then they are. And we've already done it. It's Rec 2020. So wider gamut is not a distinction between HDR and SDR, obviously, but somebody could say, okay, Steve, I get it. You can have SDR that's wider gamut, but we don't. There's no pipeline to the final viewer that's Rec 2020. It's Rec 1886 or it's Rec 2100. So if I want a wider gamut, then I need to go to Rec 2100. Anyway, I know it's 2 different things, SDR versus wider gamut, but they go together. If I want one, I have to take the other. That's why I want to point out that not only is wider gamut not specific to SDR versus HDR, but that it doesn't have the perceptual effect we're conditioned to believe. Because I've heard this over and over again where people think they're going to have richer skin tones or something. Like I've literally heard people, not just abstract creative people like a producer or director, but I've heard somebody that works as a technical job in post say they think they're going to get richer skin tones with a wider color gamut. But this is absolutely false because of what we've already been seeing again and again, which is these look exactly the same on both of our monitors here. And if I go back and forth on the viewers for the people watching the recording, they don't look sort of the same. They look exactly the same. So of course you can do something wrong. Like if you accidentally piped something with Rec 1886 primaries into a monitor that expected Rec 2020 primaries, it would look like that. But again, both of them can do this, right? The HDR and SDR still look exactly the same. They just look wrong. This wasn't what it was supposed to be. So sure, you can make a mistake, but this is, again, like saying my living room in meters is 21 meters and in feet it's 21 feet. You just did something wrong.
All right, somebody said, here's a good critique. Oh boy. This is the most ridiculously misinformed video I've ever seen in regards to HDR, but it makes sense with all the institutional inbreeding that goes on in the industry. Yedlin just seems to fundamentally misunderstand scene referred and display referred, and also seems to not understand that what is HLG already exists. A lot of people really struggle with the idea of no longer having 0 to 1 range be your working limitation. Anyone familiar with VFX pipelines know they've been working in scene referred linear for the past 20 or so years, and it is fairly trivial to remap that working space to any display. John Pius already covered it all better than I can, but all I can say is don't waste your time watching this if you're interested in learning more about HDR. The idea that HDR is a detriment is just absolute nonsense. Yedlin and other DPs like them forcing SDR and HDR containers is why you get people upset about not being able to see dark content. Think Game of Thrones ending. I can't believe this. John Pius is the blogger dude? Oh. Like, this sounds like they're falling into the trap, but also, this might be beyond me. But it sounds like they're falling into the trap of thinking, like the Game of Thrones ending didn't need HDR. It was just shot poorly. The contrast was way too fucking dark. Like, if you were on set with a camera and you were checking your, oh my God, I only do this one time when I'm setting my studio up. It's the thing you check on the, it's like, you can check like an exposure setting in your camera to when you're trying to balance the lighting for a shot to see if anything's overexposed or underexposed, if you're adjusting your triangle of bullshit or whatever. But like, it would all be fucked. Like, your whole image is just dark and you're not even having good contrast or anything. There's probably a better word there than just contrast. But the Game of Thrones thing had nothing to do with like, oh, it's because it was SDR instead of HDR. Like that sounds to me, I'm vibing it. I'm softly vibing it. But that sounds to me like the most retarded take. You're actively choosing to significantly limit what their cameras are capable of to match an aesthetic that was driven by technical limitations of older displays. They decided to make their HDR grade. This is also another thing, driven by technical limitations of older displays. I feel like a lot of people that jerk off HDR, the crazy blacks. And it's like, crazy blacks, bro. That's African. I'm just kidding. Crazy blacks, that should sound like more of a conversion to OLED things from LED or whatever, is what gave you your super deep and super dark, the ability to, flip off like zero the luminance or some bullshit. I don't know what the technical thing is. Like, had way more to do with that than, like, SDR and OLED is going to look better than HDR. Can you do HDR and LED? Oh, you should be able to. Oh, no, you couldn't because you couldn't specify zero nets, huh? I'm just vibing it, but this is bullshit, and I could read the article. Dan, you literally haven't even listened to this full video. I know for a fact, if I were to go to your home right now with a gun and break into your studio and look at your computer, and I were to check your recent Google results, what you would say, what you just Googled was debunking Yedlin video on HDR. I know you Googled that, and you found the first blog you can, and then you posted it into the fucking DGG chat. Okay? Stop. I know that's what you did. So don't scream at me to read a 4-paragraph article that's citing an AI-written, ChatGPT-written blog post that's a response to a 2-hour video from the cinematographer of major Hollywood productions. What? They decided to make their HDR grade look the same as their 100-nit SDR grade side by side, which is a horrible way to work because of perception alone. If you were doing that, you were effectively putting a volume limiter on the brightness that someone can view that content when watching on a Dolby Vision capable display. Essentially the same. Are you though? I don't understand why. Essentially the same as an audio engineer forcing a volume limit on a music master. I imagine you could have, would this be the transfer function or whatever? Like, are you telling me that if you had a monitor that could theoretically display 10,000 nits, that an SDR thing couldn't do that? Whatever the 0 to 100% display that, like an SDR only whatever monitor that goes up to 10,000 nits, the 100% would just be set to. There literally is relative a loudness max question mark at 0 dB on line levels. Sure, maybe, yeah. Yeah, actually, I kind of feel like doing this in music is the weirdest thing because you do have a volume limit on everything, no? Actually, it's probably a lot more comparable to video stuff, because when you start digging into the fucking, oh my god, bro, what did I don't know, so much random retarded shit. A lot of the, or it's all actually, it's all just stupid fucking like fucking this, all the graph shit, all your transforms and your functions and your Fourier and everything that has to do with all that bullshit. It's all, there's a lot of that in audio, there's a lot of that in video, there's probably a lot of that in everything, I guess. Essentially the same as an audio engineer forcing a volume limit on a music master. Not everyone is going to watch your content in a controlled environment. Almost no one, in fact. So actively choosing to ruin those people's experience or to try putting on training wheels on it is very misguided. Now, isn't that what, arguably, isn't that what HDR would do more than that? Not only that, almost all of those SDR and HDR container masters would look singularly better if they pushed even just a little beyond the 200 nits limitations they're applying themselves. Dull, overly tone-mapped highlights aren't particularly compelling to look at, nor are the overly lifted shadows. Yedlin doesn't make HDR content, so listening to him discuss it isn't really worth the while. He treats his audience like they need training wheels and puts SDR in an HDR container. Doesn't even understand. Damn, big HDR is really out here fighting for their lives on these forums, huh? The whole discussion about film grain is also a bit ridiculous. It's already been solved. A little more bitrate. It's not complicated. I feel like film grain would be one of the hardest possible things to get correct on an encode, right? Because when you're doing compressing, you're trying to like ideally find like similar information frame to frame to reduce the overall amount of information. But film grain, I'm guessing, is like what they're talking about, like what I'm thinking when they say film grain, like little random dots or whatever that kind of make a thing look more authentic or whatever bullshit. I feel like this would be some of the hardest stuff to encode because it's literally somewhat random, right? Like how do you even compress that? Unless I'm misunderstanding what they mean by film grain. If you disagree with his perspective on this, why not professionally challenge those ideas with a presentation of your own or contact him and ask if you're willing to debate these issues publicly? Damn! Damn! AV2 is a new video codec, and from what I can read, it can add fake film grain after. Has AV1 even had mass adoption yet? I'm actually still using VP9. If I recall, the AV1 encoder removed the film grain and simulates it because it's so difficult to compress. Yeah, I mean, film grain, it literally is like it's like fucking, like imagine trying to compress like white noise. Like, you're, holy shit. I don't even know if you could actually. Maybe definitionally you can't. I don't know. In fact, I'm sure Dolby would be happy to get involved and maybe even sponsor it. A Dolby-sponsored HDR, SDR debate. God damn. Wait. Oh, this is the blogger, the John Pius guy. It's him. Oh, he's here, right? Oh my god. 287 posts. Woo! He's shown up. Why is this guy so fucking anal pained? In real-world grading and mastering environments, HLG offers less precision and highlight control, less consistency across displays, and less support across critical stages of post-production. Listen to this guy's post. While it may seem counterintuitive, it is not absurd to argue that HLG's transfer function is inferior to Rec 709 or BT 1886 when judged by practical image optimization and workflow integration. Rec 709's curve is highly refined for perceptual uniformity in controlled environments and has been tightly integrated into decades of display technology, grading tools, and calibration standards. John Pius. As Rec 709 is not supported in HDR workflows, since it was defined in the age of the now defunct CRT, and has a maximum dynamic range of 6 stops, you're not really going to lecture us about highlight control, consistency across displays, or support in post-production workflows, are you? Rec 709 has no highlights. It will clip and suffer from banding, 2 of the most disagreeable artifacts in video. HDR content across all my devices. My Asus ProArt PA32 UCDM, Apple iPhone 15 Pro Max, MacBook Pro with liquid retina XDR display, and Samsung 65-inch S90C looks vastly superior to obsolete STR. And that goes for low bitrate stream content as well. Oh my god. Bro's copy pasting from his Amazon order list. What the fuck? For all of his supposed expertise, Yedlin's, in italics, glass onion looks markedly inferior to countless other movies and TV shows where the filmmakers understood that. Imagine the audacity. Listen, I'm not saying that this makes you right or wrong, but it would just be like, I'm like recording like a fucking piano thing or whatever, and imagine fucking, I don't know, Keith Jarrett shows up to criticize me, like, for all the things this guy's talking shit about, I actually think his performance in fucking Vienna, this album was actually trash. And listening to the way that he uses I don't know I don't like the way Opeth records their shit, okay? And they're clearly dog shit at fucking recording their albums, okay? Like, Jesus Christ. Like, I'm John Pius. Who are you? What did you... The glass onion? Yeah, really? Knives Out? Really? Okay, let me talk to a real cinematographer, bro. I'm a blog poster. With the emergence of the piano, old harpsichords were used as firewood in the Paris Conservatory. The same will eventually become a vestige. What the fuck? Oh my god. This guy is ass painted as fuck. I think Yedlin's broader point is that perceptual consistency matters more than absolute technical range. A film that holds together across viewing environments often communicates more effectively than one that's brilliant on an HDR reference monitor but unpredictable elsewhere. And on your Paris Conservatory metaphor, let's not forget that most music is still written and performed on pianos, tuned to temperaments developed centuries ago. Sometimes what's perceived as obsolete remains because it still works. SDR works forever. Damn. Ooh. Ooh. Ugh. What? Yedlin spends like 30 interminable minutes of his 2+ hour presentation talking about how the PQ curve is inferior to SDR gamma 2.4. Did he say it was inferior? He sounded like the issue was that the problem is that the reason why you need so much is it, if you say 8 versus 10 bits, is it a higher bit rate? Isn't that correctly there? The reason why you need these 2 additional bits worth of space to define your brightness is because you need all of that to have the appropriate number of stops, or the distance between your stops to have it so there's no banding, right? So I don't think he necessarily says the Pico curve is inferior, but yet you need all the additional bits because of the way that, or maybe I guess it would be the Pico curve. But what is he wrong about here? I wish this guy would say what he's actually wrong about. This guy is paid by big HDR. Yedlin says during the presentation, the things that are actually different about HDR compared to SDR are all detriments, not advantages. The man is seriously unwell. I can assure you that had I written half the nonsense Yedlin says during his presentation, over at the Lift Gamma Gain forums, as much as they despise HDR, the colorists would have been all over me like a swarm of angry wasps. Because Colt. Here's a transcript that Adam Rain fed to ChatGPT that was made into an RTF file. Correction, it is not a transcript. What it is a summary of the presentation. Adam first fed a transcript of the talk to ChatGPT. Then he broke it down into sections and emphasized the key takeaways.
Maintenance report to Tunnel 3. Immediately, Tunnel 3.
Oh, this is like his pre-work that ends up in his blog later on. Oh my god. Look at the title, the link for the original blog post title. Steve Yedlin's expertise is a sham.
Communal kitchens out of fuel. There's cold dinners left, but check the other food stalls.
Attention all, my barrel's leaking, so avoid the shiny puddle.
Nobody cares. Too much, little bro. Damn.
So if somebody wanted it to look like this, I don't. This was my movie, and I don't want it to look like this. That looks bad to me. But if you wanted it to look like this, you can do it perfectly well in the narrower gamut. You can do it in either because it's perfectly convertible. Because everything within the gamut is perfectly convertible. And none of these skin tones are anywhere near the gamut edge, not even those more saturated ones. So both of them can perfectly well show this. So you're not going to see richer skin tones because of the format. Again, if you convert correctly instead of incorrectly, they're going to look exactly the same. And if you do convert incorrectly, then that's not an attribute of the format, that's an attribute of being inept. Because again, everything within the gamut is perfectly convertible, but it is true, if something is in the Rec 2020 gamut but out of the Rec 1886 gamut, it actually would be true that it's not perfectly convertible. You can get the closest color that the other color space can make, but you can't get exactly that color. But let's look at what that really means. Let's look at what kind of pixels even might be inside of Rec 2020 but outside of Rec 1886.
Yeah, let's
So this
look.
is a plot of this shot. Where are the different areas of the frame in the CIE hull? So clearly whatever is red, which is probably this stuff here,
Yeah.
even that's not at the gamut edge, but his skin tones are going to be somewhere in here. You're nowhere near the gamut edge. You're not limited from having more saturated skin tones. The fact that this is his skin tones is because that's how we wanted it to look. If we wanted it to look more saturated, we would. It doesn't look more saturated because it's in a format. The format's perfectly capable of transmitting these. Even this shot with fire is not at the narrower gamut edge. None of these shots are even anywhere near the gamut edge. They can get much more saturated. Okay, this one has a few pixels in these super green LEDs that are getting, this thing's not even on it, but it's getting to it. But the skin tones are nowhere near the narrower gamut edge. And then even a shot like this, keep in mind too, this is not like most shots, right? I mean, this is like a very specific thing. But even a shot like this is what we were after. This is our author's intent. And yes, there are a few pixels in here that are up against it.
But there's lots of other very red pixels that aren't. And when we were authoring this, I didn't wish it could be redder, but this was a limit that I couldn't get past this redness. This is as garish and as vibrant as I personally would want to go. And again, this is just like the Sisley highlights. Even if somebody else has a different taste and they want more garish than I do,
It's still going to be these scattered rare pixels that have these incredibly narrow band illuminance.
either in the shot or lighting the shot.
Because what if instead of a saturated light source lighting neutral objects, we have a neutralish light source lighting saturated objects?
If you have a neutral-ish light, it can be cool or warm or kind of green or whatever, but it's anywhere around neutral, and it's falling on a normal object, even one that's a saturated color. Like this one has a lot of different saturated colors in it. With the cereal box, has blues and there's reds and stuff. Now, when we render colors on the screen in a final movie like this, we don't do it photometrically correct. We're not even trying to make them the exact same color that they were in real life. We're trying to make them close enough that you know what it looked like, but more beautiful and artful. But any realistic and or generally artful rendering of neutral light falling on anything reflective, not just skin tones or white walls or gray cards, but even things like the blue of his shirt, all these different colors in the cereal box, the cyan in this poster, the red in this poster, because they're all reflective colors, you're never going to be near the gamut edge. So it's not a limit on anything like that. And if somebody's saying they're getting different skin tones, that's absolutely absurd. Just to really drive that home, this shot is a great example because, again, we're looking at a fully uncompressed master quality image. It has my color transformation that I like to prepare the image for viewing, but it has no color grade yet. And when we actually graded this shot for the movie, to my taste, this was too much. So she's got a sodium colored light on her. I mean, look how orange she is. So to my taste, it was too much. And in the final grade, we actually pulled back on this. So if somebody's saying they want rich, vibrant skin tones, I mean, this is way too much. And look at that. You're nowhere near the gamut edge. You could go even more vibrant. And in fact, I can do that right here. So if I do this, so it's already pretty garish, and I can take it to pretty fully obnoxious. And yet, look at that. I'm still not at the gamut edge. Still not touching the narrower SDR gamut edge. So this idea that you need a wider gamut for anything like skin tones is crazy.
This wider gamut stuff is not applicable to skin tones or anything like them. It's only applicable to outliers like super narrow band emissive lights.
Like a very, very saturated illuminant, not a neutral illuminant on a brightly colored object. You need the illuminant itself to be super saturated, like a laser, a neon sign, a single color LED, storefront signs where there's a really thick dye and it's backlit by a fluorescent light or something. Those things, if they're either in the shot and not blown out, like you're exposed for them, or if they're lighting the shot, that's the only place where you could even get close to the edge. So in a movie like mine, where I prefer a more traditionally artful rendering, literally nothing is at the gamut edge, and my movie's going to look exactly the same in a narrower or wider gamut.
But even someone who has a different taste than me and wants a more contemporary, vibrant, dazzlingly saturated look, even they, no matter how far they wanted to go with it, would only ever actually be limited by the narrow gamut at the most extremely saturated objects anywhere in the movie.
So that what that means is there's going to be a few pixels here and there, like this shot doesn't have it, 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 this shot doesn't. Okay, this one might have it. So for the way I wanted this movie to look, I don't need to get past a gamut edge.
But even for someone who wants a much more vibrant, saturated look than I'm after, it would only be a very small percentage of the overall frame that's outside of the narrower gamut. Just a few of the most saturated green pixels here and there in these LEDs.
So that's what I mean when I say it doesn't have the perceptual effect we've been conditioned to think.
Because the overall effect on a traditionally color graded movie is literally nothing.
And then even in the most garishly color rendered movie, it would be a very small amount of pixels, a little area of some frames here and there. It would not be, this is what your movie looks like in HDR, and this is what it looks like in SDR, and then the whole picture changes. That's just simply not what it is, if you're doing it right. Again, you can do it wrong, and then it's an attribute of doing it wrong, not an attribute of the format.
Damn.
The next one is, a standard that's not standardized doesn't work. Patches that merely fix what's broken are marketed as premium services. So earlier when we were looking at this thing, I said it's nominally absolute, and I said that later on we're going to talk about how it's not actually. Nominally, the format's absolute, but we see that it's actually not, because when consumers have their expensive HDR TV at home, guess what? The knobs for changing the overall luminance aren't locked out. So it does actually go up and down. Also, new TVs, there's a bunch of models that have sensors for the ambience.
They do.
And they adjust to it. So it's not even doing what it's supposed to do, which is absolute, which ironically is good. I think it shouldn't be absolute, but the problem is the format is supposed to be absolute. And then, of course, also because it's absolute, if it sends the number 0, the monitor is supposed to literally be fully black. And if it sends 1, it's supposed to be 10,000 nits. And almost no monitor can do either of those. So if the monitor is not going to do what it's asking, and especially if you put something really high up here, the monitor has to figure out what to do.
Which seems like a bad way to do it, because a color space should communicate the author's intent, not communicate nonsense and then have the monitor guess what it's supposed to do.
So it's not like it's nominally absolute, but it's actually relative. It should be relative. It's nominally absolute. It's actually nothing. It's just a mess. So because it's a mess, we have these patches that go on top of it.
What a man. I came into this HDR neutral. Now I'm just an HDR hater. What was the argument for the absolute value y-axis? My God. Wow. Cringe.
They're not instead of it. They're on top of it, like Dolby Vision and HDR10+, which the fact that they even sort of fix it, then they're premium services.
I mean, we had a system that was working and we broke it. We know that to transmit the author's intent and for the thing to look the same, we have to maintain relative contrast. And we also know that to transmit the author's look, we have to be able to change overall luminance. And all of the SDR systems were perfect for this. The color space itself transmits only the relative contrast, and the overall illuminance can be changed by the exhibitor or the viewer to adapt to the surrounding environment and or because of limitations or exceptional abilities of the display device. So the thing was working great, but then we entangled relative contrast and overall luminance right when we shouldn't. And instead of fixing the problem at the core by not doing that, we have these patches that go over the problem. They change the relative contrast even more, but they at least fix it so that the thing doesn't look totally messed up. And then we have an imperfect patch on a problem that never should have existed, sold as a premium service.
I don't mean to disparage Dolby, because they didn't make the problem. They made a solution, and at least, I actually have some complaints with how they did it, but at least they have a fully packaged thing that does work within its own thing. I'm going to tell you some things that I disagree with how they do it, but at least it actually works.
Because HDR on its own doesn't. And
also, when I say I don't want to disparage Dolby, I really do think they have really smart people there, and maybe they can also take the lead in whatever this next thing to get this mess behind us is. Maybe they can help lead the way on that. So you can see how the thing doesn't do what it's supposed to do. And then we have these patches on it. And then those patches, they don't go back to making it, okay, now we do keep our relative contrast. They change it even more. And it's not even fixed. Like, this transfer function is fixed. The stuff that they're doing is dynamic, where it's changing depending on the content of the shot. Of traditional proper color space, like Rec 1886. It tells the monitor what it should look like, and the monitor obeys. But the way Dolby Vision works is it's not a one-directional thing like that. It's a negotiation where the monitor is saying, hey, I can show this but not that, and I can do this but not that. And then it's changing the relative contrast of your movie, which makes your movie what it is the relative contrast. I mean, obviously there's a lot of other things like script and stuff that make your movie what it is, but in terms of the tonal rendering of the movie, the relative contrast is what makes the thing what it is. But the fact that we weren't able to get a good representation of relative tonality, and then the thing that fixes it changes it even more, but it's the only fix we actually have, so it's a premium service. Okay, so then the next one is edge cases and outliers marketed as the crux. So we actually already talked about these separately, but I just want to put them together, which is we saw that the only actual practical difference, not stuff that's just double talk. The only thing that HDR can actually do in practice that SDR can't is it can punch through the ceiling right now because it has an artificial ceiling and SDR doesn't with your highlights. And 2, the implemented HDR, when it's not a thought problem and it's real life, the implemented one has wider gamut than SDR. That's literally it. But as we saw, these are total edge cases. So in a movie like mine, the way that I personally like my tonal and color rendering, 100% of the pixels in the whole movie can be shown exactly how I authored them and how I wanted them in both formats. It's not like some of it's in the gamut for the one and out of gamut for another. And it's not like some of them are blowing through that artificial ceiling, so I can't do it in SDR. So for a movie like mine, literally every pixel in the whole movie is perfectly convertible. But even for movies that do want to go super garish, we've already looked at this, it's only certain pixels here and there. It's not like the crux of the whole thing. They can do things like this, And if it isn't something like this, if it's the whole shot, that isn't applicable to SDR versus HDR. It's just a different look. So a shot like this, they can do that. So these are edge cases. So the punch through the ceiling thing is only applicable
I wanna
to
be edge
little
case.
pinpoints of sizzly highlight. And the wider gamut thing is only applicable to the most absolutely ridiculously garish colors where it's already looking electronically garish and you want to go even farther with it. So it's a few pixels here and there. And then they're saying it's going to be vibrant and bright, but edge cases are not the crux. You can get that same overall look. Again, with a look like mine, you can get the same look perfectly. But even if somebody wants to use HDR, HDR is not a look, but if somebody wants to use it for a look that it can do, that's outside of the bounds of SDR, it's only going to be some pixels here and there. It's not going to be a substantial percentage of every shot looks like. Okay, next, loud fallacies and word salads keep us from reality-based mental model and from questioning marketing gimmicks. And that's why this demo has to be so darn long, because if everything made total sense, but there was just one little thing wrong, we could just point to it. But, we see this in politics with flooding the zone or the Gish Gallop.
Or whatever you want to call it, where they throw so many wrong things at you that you can't get back on track because you don't even know where the track is anymore.
Hello? Destiny fan? Hello? Yes, he is. And then he's going to be like, this is why I had to make this 2 hour and 20-minute video. It's a little bit of tit for tat, okay?
And we've seen how many of these there are. There's the talking about HDR where you're switching between a monitor and a signal that's driving the monitor, and in the middle of a sentence switching between those without saying you are, or confusedly lumping them together. There's saying SDR is 100 nits, saying that HDR, the overall luminance, is quantified by the single brightest pixel.
Making it sound like inefficient use of the data rate is an advantage.
All of these things we've been looking at, look how many of them there are. And then there's even one we haven't even talked about yet,
What?
which is
Another one?
thing that I've heard multiple times from HDR upselling hucksters saying, well, we have to change your
Upselling
relative
hucksters.
contrast because it's a 2 million to 1 contrast ratio instead of a 2,000 to 1 contrast ratio. So they're saying this stuff that's supposed to scare you that the outer contrast ratio is so different that something else different has to happen. But the thing is, this is not a way to quantify literally anything meaningful perceptually, because the outer contrast is dividing the brightest pixel by the darkest pixel. But all these monitors are so good.
Wait, Dan uses these talking... Hold on. Wait, what? The available color gamut is simply superior for darks and brights. You can't possibly get lifelike shit when your content is mastered. For 100 nits versus 400? Oh no! Oh no, Dan! Wait, but you can master it for any nit level for SDR, no? Theoretically, you could, right? And then what is this? Oh no. And then Dan posted the gamut thing. But that 2020 color space that he has HDR next to, this doesn't have to be for HDR. You could theoretically use the same color space for SDR as well, right? Oh no! Oh no! Dan fell for big HDR. He posted the gamut he fell for the triangle. He fell for the larger triangle, guys. He thought that HDR meant larger triangle. What a fool. I'm just kidding. I'm sorry.
That the black is almost 0. And when you divide by 0, that's undefined. And as you approach 0, you just get comically big numbers that don't mean anything. Because if I had a monitor that could go from 1/1,000,000th of a nit to 1/1,000,000,000th of a nit, that would be a 1,000-fold change by their definition. But literally, you wouldn't be able to see that. Nobody can see the difference between that. And just to actually look at that, not the trillionth and billionth, but some other comically big numbers. Okay, so I'm going to make a change here. See that change?
Wait.
I can see it, and I'm
Okay.
not saying it's not there. It's kind of subtle though, right? It's getting a little milky. So based on that definition that they've got going there, that is a 1,000-fold change in the contrast of this shot, because the white is staying the same and the black is going from 0.0001 to 0.1. But I mean, we see why that's absurd. So they're saying that is a 1,000-fold change, but that is a 2-fold change.
Wow.
It makes no sense. It sounds like it's quantifying something perceptual, but it's not. It's just nonsense. There's no reason to divide the brightest pixel by the darkest pixel. It doesn't tell us anything. What we're tuned into is an overall luminance, not the brightest pixel divided by the darkest. And I'm not saying that's invisible. Some movies, they like a small lift to their blacks and some don't. I'm not saying it's nothing, but that's just a minor decision in the rendering. There's nothing perceptually that's changing by a factor of 1,000.
It's just a deceptive framing.
Okay, so that's the word salad section. Gish Gallop, flood the zone. Okay. Next one, conditioning us to think that the photographic look is dictated by the format rather than by the filmmaker's intent. This is what your movie looks like in SDR, and this is what it looks like in HDR.
Whoa.
Even though this is coming up here as a bullet point, it's sort of the whole thing, because HDR is a format, it's not a look, and the author should be able to decide whatever their movie looks like, and then the format transmits it. Again, just like when the architect designed my living room, they design it, and then you can use meters or feet to transmit it to the builder. That doesn't make it come out different. That's just how you transmit it. So the filmmakers should be able to decide, but in real life, not theoretically, you have all the way from shooting, post, to the final consumer, thinking that it has to look different. They're being told this is what your movie looks like in SDR, and this is what it looks like in HDR. So we've got cinematographers and gaffers standing on set looking at two monitors that look completely different from each other with different overall luminance, and they're lighting to both of them. I mean, this is absolutely absurd. Why don't you pick which one you like and then make the other monitor look like that? You know, if you're the author of this, not the format. The hilarity is,
If it actually did that, it'd be an even more problematic format than it actually is. It just changes
That
whatever
is hilarious.
you give it. That would be like if the Postal Service advertised that we never deliver to the address you put on your letter. We only deliver it to a better one. But if I'm the author, the best thing you can deliver is what I asked for. Not to say, no matter what gets ordered up, something else is going to get delivered.
the thing is, it actually doesn't do that. The reason we're looking at two totally different things
Is not because of the format itself, but because of these misconceptions about it.
and that happens all the way down. So you've got it on set, you've got it in post where people are color grading with two totally different looking monitors next to each other. And then you've got it with the consumer where people will buy two discs of the same movie and then go complain on message boards that they do look the same. So this disc has successfully shown you what the filmmaker
Oh my God, they laughed. They were laughing. Okay, I'm gonna get a drink real quick, and then we're gonna run this trial. Wish me luck. Hold on.
decided.
You know, like the Comp 3 on anvils? You know, if I'm just shooting arc, I probably want the hit scan more than the fucking... I think the circle's small enough. The circle's small enough.
And you're complaining that they're both successfully doing it. You want one to do it wrong. So this problem's going all the way down from the very beginning to the very end. And again, I apologize for how long this is, but this is, I promise this is the only bullet point that has this. This bullet point also has sub-bullet points. So the first one is using faulty conversions between color spaces. So this can happen for a few reasons. One is just obviously there's so much confusion as we're talking about, and it's hard to just do things right. And somebody can just make a mistake. And also the reason I'm advocating all this stuff is because some of these concepts aren't there. Like it actually might be a little ambiguous how to convert perfectly between the two if you don't understand A, the idea of scene white, and B, the idea that SDR is not actually fixed at 100 nits. So there's that, just it actually is a little bit difficult to navigate the world. So somebody might just do it wrong. It's nuanced. And, you know, another reason is, although there are tons of really smart people that know their stuff out there, like our colleagues here at Photochem, there's also a lot of con artists who just say the word color science, but they're just twiddling some knobs that they don't understand in some software that they bought, and they don't really know what's going on. Another one is confusing color grading style with format, which in a way is sort of restating the problem itself. Here's your movie in HDR, and here it is in SDR. But that's not a mistake that this is sort of a restatement of the premise, because it is a feedback loop. People are told HDR looks different, and then they have to make it look different, so they grade it different. And then they say, see, HDR looks different, and then you grade it different. But it's just two different grades. You can do that in either one. That's not an attribute of HDR as a format or SDR as a format. It's an attribute of just people grading things differently. The next one is falsely claiming that SDR is capped at 100 nits. So we've already talked about this several times, so you already know that's false to claim that. But I want to talk about it in this application, which is, I've seen this again and again. I don't do it on my projects, but I've seen it where on set people have two monitors next to each other that look totally different, or in the color grade. And if you cap the monitor at 100 nits, then you're going to think it's different, but that's wrong. And when you look at them next to each other, your eye is going to adjust to the brighter one, and then the other one's going to look dingy even if it isn't.
So right now, I'm going to keep relative contrast the same, just change overall luminance.
I'm going to put our SDR monitor here on the room at 100 nits instead of 200. I'm going to show that on the computer screen for the people watching the recorded version. So it's going to look dark. But when they're next to each other, it's going to look dark. Of course it is, because your eye adapts to surroundings. So if you put a dark one next to a light one, your eye is going to adjust to the bright one, and the dark one's going to look dull and dingy. But you can either just put the SDR one up to the same scene white as the other one, because SDR isn't limited at 100 nits, or You could take the HDR one away so your eye adjusts to the 100 nits and then, and it's going to look fine. So this putting them next to each other at 100 nits is just completely disingenuous, not only because that's not true that it's capped at 100 nits, but also because even if you do want 100 nits, because it is a darkened color grading room, let's say, then you shouldn't have something really bright next to it. Before we were ever talking about this, when there was only SDR, not HDR, you wouldn't go into a darkened color bay, set it at 100 nits, and then put a light right next to it and shine it in your face and then start color grading.
The 100 nits is explicitly for a darkened color grading environment, not for when you're looking at the monitor right next to something much brighter that's blasting your eyes out.
It's just a disingenuous way to compare these things. Okay, next. Falsely claiming that photographic reproduction's tonality always has linear relationship with the photograph scene when in fact it never does.
It's been understood for decades by color scientists in both academia and industry that for photography to be pleasing, it needs to not be photometrically accurate, but to be accurate enough so as to be evocative of what the original scene looked like. But then it also needs to be artful and not literal. So the photographic rendering is not only permitted to be artful as opposed to slavishly literal, but actually must be. But something that I've for real heard from people doing HDR upsell stuff,
where they say something like, here's your movie in HDR and here's your movie in SDR, and they've just chopped all the highlights off of the SDR version. And I go, why are all the highlights chopped? And the answer is, well, because we can't show the contrast. This scene had 10,000 to 1 contrast ratio, and we just can't show that. And firstly, as we saw, the outer contrast ratio doesn't mean anything, but also we always map whatever the camera got. It's not what the scene was in real life. We map whatever range the camera got. Our best cameras today get something like 15, 16 stops. We map that into our photographic rendering without chopping any of it. And we don't just sometimes do that. We always do it. It's not just like, oh, it's possible to not be literal in the photographic rendering about the relative contrast of the scene. It's not just not enforced. It literally never happens, ever. So let's take a look. There's a lot of different ones of these, but this is sort of an average lookup table, the standard color transformation to take the...
Hey, I attended Steve's actual closed-door demo at Photochem in LA. Happy to help clarify. Wait, you mean this thing that we're watching right now you did? Wait, why are you in chat? Why the fuck? What the fuck?
Logarithmic, uninterpreted camera original.
Post a pic you took with him then.
Compare it with a artful
I don't believe
cinematic look in a gamma encoded color space like Rec 1886. And yes, it's linear-ish, because when they're saying that the relative contrast in the rendered movie has to be the same as the original relative contrast in the scene, they're saying that you would have to have a linear representation of everything. But we never do that. There's a linear-ish in the middle, and we always make those beautiful, gentle highlights. We don't chop them off. We don't just keep going here and then right at the top chop all the highlights above there. We lean them all in, and that's what makes it look beautiful. We do the same thing in the toe. And this is an average of a bunch, but this is a cinematic-ish one. But even a more clinical-looking broadcast video version of this is still not a straight line. It's still going to have some version of a shoulder and a toe. It's just going to be a slightly more electronic-looking one, but it's still going to have that. So we literally never do that.
We always take all the information that the camera sensor got and fit it into our tonal range. We don't chop it off.
And I just want to show, because somebody could say, and they'd be right, they'd say, well, Steve, you're graphing the wrong thing, because you're not graphing the relative contrast in the original scene to the relative contrast coming out of the monitor. You're graphing a logarithmically encoded camera file going to a gamma encoded image file. So let's do graph it the other way. And all that does is shrinks the bottom and expands the top. Now this is a graph of relative contrast on the original scene to relative contrast physically coming out of the monitor. And it still has the toe, straight line, and shoulder. But because we're graphing it in original linear instead of log, so it squeezes the units around. But of course it looks exactly the same. Okay, next one is falsely claiming that changing the overall luminance demands a change in relative contrast when the opposite is true. So we've seen this again and again where they're saying we have to change the contrast because it's so different. But no, what we saw as the opposite is true, is that what makes the thing recognizably itself is the relative contrast. The thing that you need to do if you're going to change the overall luminance to maintain the author's intent, you have to not change the relative luminance. We're being told because you change the overall luminance, that's a reason you have to change the relative. It's the opposite that's true. To preserve the author's intent, you better figure out how the relative doesn't change when the absolute does. Okay, next. Conditioning us to think that an image isn't in a given color space unless that image...
I don't understand a thing he said the whole time. I guess, like, basically there's like... I Actually, I don't know how. The only thing I was going to compare it to would be autistic music arguments, but that would also be autistic. There are ways that you can play an audio file where you can have a greater amount of digital information or you can have a lesser amount of digital information. So space isn't as big of a deal, but back in the day, like MP3 formats are really important because a CD could only hold anywhere from 10 to 15 songs. I think a song was, like anywhere from 70 to 120 megabytes or something on a CD. Yeah, and MP3's got that down to the 2 to 7 megabyte range, I don't know, 2 to 5, depending on what type of MP3 we're talking about. And you can argue, there are some formats available, like WAV, I believe, is a little compressed, I think. FLAC would be like also more compressed but lossless, so that you could still recreate the bit-perfect copy of the original file or whatever. And then you get into MP3, which are lossy encoding files, so you're chopping away some information to make a very, very compressed file. And you might want to argue for or against what type of compression you want. So you might want to argue, well, I think that a non-compressed video file is better for this reason, or I think that a compressed file or audio file is better for this reason. But it sounds like the big issue that this guy has, although to be fair, I don't know any advantages for HDR yet, but it sounds like a big issue this guy has isn't necessarily HDR versus SDR. It's somebody saying things like, I really want my guitar to sound nice and crunchy. I really want this electric guitar, and I just need the crunchiest sound possible. That's why I only have my music playing in the WAV format. I have the most beautiful vocalist, and she's got the most, her voice rings, and it's beautiful, and the reverb. I need the reverb in the song, and that's why I only use FLAC audio files. I would never hear that reverb, that beautiful reverb in MP3. And it's like, no, that's not really going to impact that at all. You're talking about, we're not even close to talking about reverb because of your file format. It's not really an appropriate analysis. And it sounds like what his issue is people are saying things like, you want a lot of contrast in your image, you need HDR. And it's like, no, that has literally zero impact whatsoever. As long as your SDR, as long as the contrast is set up appropriately, you can do the exact same thing between an HDR or an SDR thing. The only question I have now, I guess, after watching this, maybe this guy is an HDR hater. I don't know what the fuck the point is of HDR at all. Other than maybe doing like a studio reference version of a thing. But my guess is, and he said it earlier actually, that HDR monitors probably don't even show necessarily the true HDR because they might have sensors to detect for relative light in the room or something. So I don't know.
Pushes up against the edge of what that color space can transmit. People saying if it's HDR, you have to punch through the ceiling or you have to make these garish colors, otherwise it's not. But that's absurd because, again, that would be like telling the architect you have to make the thing a different size in meters than in feet. The unit can transmit whatever it is that you want. And a great example of that is, as we were looking at here in this absolutely beautiful movie, like these whites, not only are they not punching through the ceiling, they're pointedly not even getting to the ceiling.
Yeah, they're not even probably at 100%, yeah.
And that's what's beautiful and gentle and creamy about them. And the thing is, of course the thing can transmit something that's not up against its edge. The fact that one color space gives more options doesn't mean you have to take them. It's just more options. The author should be able to decide what they want. And again, we're looking at this in a Rec 2100 color space, and we can actually represent the original decisions, and we don't have to distort it and make everything more saturated.
Okay, we'll watch the rest of this in a second. Hold on, I gotta do my trials. There's only 20 minutes left of this. Okay, also, there's a chance I might not stream tomorrow. Listen, okay? I watched the first 2 episodes of this show called The Pit. What the fuck? How you guys have been keeping this Kino from me? What the fuck? Holy shit. I'm kind of worried. I don't even know if I can keep watching it. This is a very, very, very strong first 2 episodes. What the fuck? Does it maintain its quality? Or does it... Oh my god.
We've arrived.
Yeah, I have. Oh my god. Are you actually British? Wait. Oh no, it's you again. You're
Why
not.
do you keep fucking accusing me of being British?
You're not- you
Also, I
have-
don't have enough ammo, I don't think.
I don't have enough ammo?
You get like 3 stacks, bro. Let's get a 40-minute fucking trial.
Okay. Have you ever seen a TV show called The Pit?
Yeah, we watched it in chat for a bit.
For a bit? You didn't even finish it?
No, I think I watched like 1 or 2 episodes.
Oh my god. Okay.
Oh fuck, season 2 of that is out now, eh?
I think it's just starting to, yeah. Or I don't know if all of it is. Maybe it's all out.
Nice.
Okay. Are you a good... Wait, are you a Cantina legend as well? I bug bug.
No, I'm what am I? What's it called? Hot shot.
Yeah.
So hopefully next week.
I'm in fucking Daredevil 3 like a fucking scrub.
And get the 3x.
I don't think that's
1x? Wait,
possible.
Daredevil?
I think once you start to get...
1x and get on my level.
Yeah, I think when you get to these higher ones, you can only promote once at a time.
Yeah.
Then you can only promote the hot shot, then you have to go from hot shot to cantina.
Yeah, that's what I just fucking said, okay?
Alright, start.
Yeah, but there's
Start,
like more
start.
authority from like a cantina.
Yeah, but there's less authority from you being 19, so...
Are we so I'm gonna go to control tower. Are we like aiming at certain spots, or just if you see one, go for it?
I feel like we kind of have to be together, no?
No, you split.
Are you sure? Our queues aren't going to be fucking...
You're in the fucking... I'm in the friendly queues. You
Okay.
better
I'm
fix your
saying-
fucking
wait.
queues.
Because when me and Mooten and
Because if I lose 200K...
Prime, when we did this last time, bro, there were like fucking 20 teams, okay? It was some fucking death match. What was the name of that movie? God damn it. With the bow girl? Crossing Fire, Dying
Hunger
Thunder?
Games.
Hunger Games, that one, yeah.
Hunger Games.
Oh my god.
Are you in demon queues right now? Am I gonna lose all my shit?
I don't know, I never played trios.
Oh god.
We'll be fine.
That would be totally fine.
Surely.
Load in, you fucking losers. Wait, do we have to kill... Are we killing people then, or are we just... No, we have to kill people, right?
No, just
No, you just fucking sit in your little tower spawn and you shoot arc.
They're gonna be taking arc from us. We don't kill them.
And every gang in Toledo is scrambling to get their hands
Okay,
on whatever's
I'm just
in
gonna...
bastard. What do you mean?
I'm gonna watch
go to waste.
Salted.
Pick a spot.
It's gonna be behind him.
Okay, I'll go to the spot.
Okay, I'll go to launch
trench
tower.
You gotta pick one.
Go to that location.
No, you have to go. The spots are this,
North trench tower.
this,
To that location.
this.
Okay, I'll go up there then. There's no shot that we can do this alone. We're dead.
I've done this before.
I don't believe you. What's
Like
your...
3 times.
Oh my god, okay.
Not 100K.
Okay.
I did one today. I did one yesterday.
Why do you keep doing them?
Because I want more points.
Hornets.
I didn't do them optimally last time.
I'm losing my shit. Destiny's gonna start firing at people.
What? I'm killing the Hornet like I'm supposed to.
Go to that location.
This extract's gonna ship them. I'll ship them in. Yeah, you also want to get the sniff scanners.
The fuck was that noise?
The
Oh,
little
somebody's
thing for the-
doing this bullshit.
You can steal some of the hornets from them as well.
Oh, true.
Yeah, did it over here.
There. A hornet. Hornet.
Oh my god, dude, I'm getting Hornets like crazy. Oh fuck, they're shooting at somebody else.
I feel like I'm gonna get shot.
Why? I thought your cues were friendly, bro.
Well, yeah, but yours aren't.
Whoa, team of 3? Okay. I'm so friendly.
My God,
Just killing hornets.
this is a friendly.
Oh god. They're gonna kill me. I can feel it.
But I think they're also doing the trial. They're sitting up here.
Antenna has been successfully activated.
Wait, if they're doing the
Well, no,
trial-
just getting the antenna. I'm fine.
Oh.
All right, nothing's happened so far.
What? Oh my god, that guy's gonna backstab us. He just left. He's a troll in chat
Just a
too.
name. I made it.
I should have brought fucking adrenaline, bro. I'm fucking retarded.
Yeah, you are.
Well, fuck you. I was just kidding. You're supposed to make me feel better.
I honestly think it spawns right now. Oh, I got face already.
Oh my god, shock my balls.
You gotta kill all the wasps as well. They fuck with the spawns.
That's fine. Wait. Oh. The team that I saw, the team of 3, they ran to the place.
My Discord shit the bed. I don't know what happened.
No, it's all good, dude. You know, we understand. You just wanted to fuck off and whatever. And troll.
Let's go to that antenna.
Okay, I can't go up there then because those guys are there.
Antenna. Let's move to that location.
Where,
Go to that location.
They're just doing the antenna. You should be fine.
Oh,
Go up
you're
to
right,
them,
you're
just stay
right.
friendly.
That's right.
Attention raiders, the north antenna has been activated.
Please? No? Did that go over? Good luck, me. And before. I should have just brought a fucking hook zip thing.
Your zipline's not.
No, hook shot, whatever the fuck. I don't know what it's actually called.
Snap hook.
Yeah, a snap hook. Oh, this? Absolutely.
Raiders, the west antenna has been successfully
Oh my god, those
activated.
guys are using snap hooks.
Hello.
Yeah, you'll never lose them if you just put it in your safe pocket.
No! Don't crash! Oh. Oh, sorry.
Minus 200.
Sorry, I don't know what happened.
go there.
Hornets, over there.
Shit.
What happened? Are you okay?
Yeah. Good.
Are you getting PvP'd or?
No, I'm just bad.
Oh. What? Damn. Okay, we're on a good pace. Jeez.
I told you too
What
soon.
are we at?
15K.
Okay.
Oh shit. Oh, are you guys killing hornets?
Yeah.
Yep.
Oh, okay. I'll go move. Fuck. I think these guys. Oh, okay. Never mind.
I think they're just doing the antenna.
Well, they've been here for a while. I don't know why they're still here. Unless it takes a while to do antenna.
No, they should be gone by now.
Kind
It's
of
gone.
does.
It kinda does. Really? Does it though?
Yeah, you gotta sit there for like fucking 5 minutes waiting for the thing.
Oh. Well, I didn't know that.
Attention raiders. The south antenna has just been
Watch this shot,
activated.
chat. Watch this shot, chat.
Are you good?
Who? Oh.
Guy's at like 10 HP.
I'm fine, everything's fine.
It's fine, it's fine.
Wait, is this broken? Hello?
Yeah, but I lied about the Jupiter. Like 2 shots, Hornets.
I mean, is that good or
You can
bad?
get it one shot if you hit it from the ass.
I just one-shot one.
It just has to be from behind on like the cylinder.
Radiant, I'm higher than you will ever be in your trials ever, kid.
Oh. Got him.
A wasp, there.
I snap one face down. You're the closest.
Oh, me?
Well, yeah, you just.
Oh, I just pick it to check what it is sometimes if it's far away. I'm just curious. Not that it matters, I kill all of them anyway, so. Oh, shot. Oh. What? I didn't just get shot, did I? Please.
Show it.
Fuck. Wait, are you shooting at my thing?
No, I'm not shooting at you.
I'm shooting vaguely in your
Oh my
direction.
god. Okay.
Like, kill him, you know? There's still one up there.
What?
Here, I'll let you finish it off, buddy.
Like a bad guy?
Yeah, what?
That's my base place. I think.
Your best, you said?
I think so.
Oh, yeah, that's good.
Good one. Why did someone type in chat only 200 ammo left? You
There-
brought more ammo, right?
I mean, I have 200 bullets left. Hopefully it's enough. Oh my god! Holy shit, bros. There's so many things. Did you pull that spawner? You did, right? Okay.
Yeah,
Yep.
that's me.
Whoop, whoop, whoop.
Hey. That's not us getting fucked up by the Rocketeer, right?
Hopefully not.
Damn, that guy's fucking zooming.
I have to look next. The fuck's wrong?
The Americans have the Mazda commercial where it went zoom zoom.
Yep.
Oh, hell yeah.
Wait, where are you from?
Canada. This Hornet is fucking Maverick.
We're on a very, very good pace.
Oh, hell yeah, 44k. 20 minutes in. Will we hit 100 though?
We'll hit more.
Oh my god.
We hit 100. I go to second place. Oh, you're not going.
A Hornet, over there.
No.
Hornet. Wasp, there.
Help. Oh.
Gotta keep in mind this elevator's a little far.
Yeah, maybe for you. Oh! Stop!
Hornet, there.
Oh my god.
See you at under 100 ammo.
Don't worry about what I'm doing right now, okay? Worry about what you're doing.
Pace might slow down.
I think I'm getting shot at.
Are you?
Hornet,
I guess not
down
anymore.
there. Wasp. Got a wasp overhead.
I'm just not missing any shots.
Who's a what? Say that again?
I'm not missing any shots this time.
Good job.
Still have 40 durability on my Jupiter. That's good shit.
I have 23. You gotta shoot faster.
Wasp, there.
You know, I guess that's a good point. That's not good shit.
Oh, I just one-shot it.
Sometimes I feel like I hear things drop and then I don't see them. Whatever.
Maybe you got your headphones backwards.
Hey, Raider!
Is there fireballs up in there I can kill?
Or you're just schizophrenic.
In here? I don't think there are. There might be in that building in there, though. He's trying to kill fireballs? Is that even a thing? Oh, he's trying to do a class.
Yo, you want a ziploc?
No, I got one. I'm good. Thank you.
$63.
No. Whatever.
It's so annoying when they have one engine and they start flying like a fucking person.
How many shots is it with an anvil to kill a hornet if you hit armor every time? Is it 7 or 8? Okay, you know, fuck me. Oh, you guys aren't even using anvil, so never mind.
I don't fucking know.
Okay, well, I figure you guys are out here shooting.
I'm not an anvil player.
Yeah, I got it. You gotta use the noob cannons. It's all good. Oh my god. Okay.
It's 6-7.
Good one. I'm raffle coptering right now, dude. What? Ah! Sorry. Oh my god.
$75.
What? It just crashed into the ground for no reason.
Oh, you shot two others.
No, they're like sometimes when they're flying to you, they just like crash into the ground for literally no reason.
If they're too close to the ground, they'll crash, yeah.
Yeah, that's typically how you crash, is you get too close to the ground, yeah? True?
That's why you shoot with another gun and just let it fly up. Idiot. Yeah, I think I have like 110 pace.
110 base.
Pace.
No, don't do it. No!
A Hornet, over there. Hornet.
What?
You okay?
No. Ah, yeah, I'm sorry. What? Don't mind me.
Hornet.
90.
I'm gonna have to put this back on. Never mind, I'm good.
Head home at the east elevator.
Just pinging it.
by that building.
You've got those two?
Yeah, yeah.
Oh my god.
Wasp, over there.
All raiders, we have Ark on screen. 5 minutes left. Go find a way home. I repeat, 5 minutes.
I think I'm gonna start heading over.
Got that over in like a minute. Yeah, probably start going on.
Do what?
Start dipping.
Oh. No, wait, actually? Oh, no, wait. Okay. Right?
Yeah, IO Bob, you probably gotta be there first because you're gonna have to press it.
Okay. I'll start it now. Just say IO.
Are you okay?
Please don't say Bob. Yeah. Oh, fuck.
Wait, did you even... What is your current score on this? Like, your best for this week?
I'll say 100k.
It's what? You said over 100k? How much over?
We beat it by a little bit.
Good.
It was 100k.
Last warning. 2 minutes left. Head back immediately. The window is closing.
Oh, Jesus. Salted, you're gonna make it, right? Which one of you is that? Prying?
Yeah, no, we're good.
Okay. Oh, no, wait, you're Bob.
No,
You're...
it's,
What? No, it's IO. For fuck's sakes, dude, please.
Wait, call you Io or call you
Just
Bob?
say IO.
Okay.
IO. Do
I
not
gotcha.
say Bob.
he prefers
Nice,
Bob.
Oh god, there's somebody sitting at the extract.
Oh, shit.
Yeah, I'll get to meet you, man.
I should have brought adrenaline.
Yeah, no, we're doing the same thing, man. Thanks. I didn't make it.
I'm bad. I don't know if I'm gonna get out.
Oh, bro. Fuck. I can make it too. I don't have a thing. Oh wait, no, it's groups. I don't need a thing. I'll make it. There's somebody else at the extract.
I don't know if we'll make it and make it back.
I'll go for it. You stay by extract.
Do you have a defib or
I'll
no?
go for it, you stay by extract.
Wait, actually,
do.
do you have any wolf packs?
Oh, you're close.
I do.
Yeah?
Okay, because there's a rocketeer on me. Yeah.
You guys will make it.
25 seconds. We'll be fine.
Yo, you want to do me a favor, and if your friends get here, not call the elevator? Just wait for it to time out? My buddy just got downed.
He has to call it at like 2 seconds. Remember, we only have like...
Yeah.
Oh,
Yeah,
job.
exactly. Thanks,
Run,
dude.
Forrest, run. Here, take my snapback. Use it. It's right here. It's right there.
Did I grab it? I got it.
I think so. I got stems, so just use that to move.
Oh my... Bruh.
That's fine. I got it.
Is it actually faster if I snap like a tree or something, or what?
Yeah.
It's
We have no
100%.
stems, right? So go.
Yeah, no, you guys are fine.
Okay, obviously. No
Yeah, so
problem.
much.
Never even worried about it for a microsecond. I can't even fucking snap with this thing.
Hell yeah, buddy. Oh, there's a fucking rocketeer here.
Oh, it doesn't matter. We're at the... I don't give a fuck now.
Okay, we're good. It's dead.
That did the job. Don't hit the button. Is all your team here?
Yeah, we're here.
Yeah, we're
here.
good, man. Thanks.
Okay, wait. Nobody call. There's... 6? Are we good?
Alright, boys, I'm hitting the button.
Oh.
GG.
Appreciate it.
Good dog. I'm afraid they eyes shooting you right now.
Yow.
Nice. Good shit.
Okay.
I carried your ass.
Fuck, there's no way that we can see how much each of us contributed, is there? Oh wait, how much experience do you get?
I got 75k.
81k. Get fucked, nerd.
Fuck. Oh,
Wait, what was
gosh.
your destroyed arc? Or damaged arc?
Damage
Destroyed arc 11k. Damaged 40k.
I was at...
I got 12 and 45. So get fucked, nerd.
You know, close enough, alright? I don't believe any of you also without
What'd you
screenshots.
get, buddy?
It was like 11k and...
Oh, okay, 1 second.
I was like 4k under on one and 1k under the other.
There you go. Quick Photoshop.
Too late. Already. Yeah, you just said Photoshop, see? You faked it.
Okay, he carried.
God damn.
To be fair, I think the control tower is a good spawn, because you get like 6 dedicated dudes just for you.
Yeah.
That's what I do on Tuesday night as well.
Good one. You're on Hotshot, and then the other guy, Prize and Cantina. Okay, and I'm gonna do double 3. Jeez. Okay, well,
Yeah, they didn't do shit for me, to be honest, but...
I'm done
hopefully I'll help you
until
guys.
next week for this shit, so... Alright, have fun, be careful. Thanks a lot. Be careful.
That's good shit. Yeah.
Yeah.
Bye.
Bye.
Rank 1. We take those. Easy. The fuck even are these stupid pools? Okay, finishing this.
Or we don't have to have caustically sizzling highlights or whatever. And just to go even another step further with that is HDR as a format, it actually is good enough, despite what people say, to transmit this image. We actually can transmit it. It doesn't make it into color. It doesn't screw up. It doesn't change when the absolute does. It doesn't make, okay, next, sky way brighter while holding these other things. To transmit this image. We actually can transmit it. It doesn't make it into color. It doesn't screw up. Even another step further with that is HDR as a format. It actually is good enough, despite what people say, to transmit this image. We actually can transmit it. It doesn't make it into color. It doesn't screw up all the relative tonality. It doesn't make this white sky way brighter while holding these other things down. It's actually possible to transmit the whole thing. We don't have to be up against the edge of everything. We don't have to be the most garishly saturated. In fact, you know what else we're not up against the edge of? The screen.
There's space on the left and right. So if I were to crop in on this, so it was 16 by 9 and there's no black on the sides, and I was to colorize it, and I was to sizzle up the whites, if I did all of those, HDR would be able to transmit it. But not because only that version is HDR and this version isn't. Both are quite literally HDR because I'm sending them over HDR Rec 2100 signal. The difference would be one is the movie being transmitted over HDR, and the other is a messed up version of the movie that I created being transmitted over HDR. So yes, HDR can transmit that, but things don't have to be up against the edge of everything for it to be in a format, just like things don't have to be a certain size to be in meters. Okay, so then let's go to the next one. Comparing an HDR version to an automated HDR to SDR conversion that actively changes the tonality and contrast instead of comparing the two using a rigorous color space conversion that does keep them the same. So as we've been looking at the whole time, over and over and over again, we've been looking at many images that look not just sort of, but exactly the same in Rec 2100 and Rec 1886 because I converted them correctly as we discussed. So as we've been looking at over and over again, I can send this thing over Rec 2100 or I can send it over Rec 1886 and make it look exactly the same with our 200 nit scene white right now, but we could do it at any chosen scene white that the monitor is capable of. And they look exactly the same because I converted them correctly instead of incorrectly. So we talked about when we were looking at that list of things, one of the things we were looking at is you could convert it wrong. But what if you convert it right? But the quote right is your distributor demands that the way that you convert it is using Dolby's automated conversion from HDR to SDR, and you can't change how they do it. Well, their conversion, and again, this isn't to disparage Dolby because although I disagree with this part of what they're doing, again, they actually have a system that works on a thing that doesn't work, so I don't mean to disparage them, but I do disagree with this part, which is when I convert Rec 2100 to Rec 1886 here, they look exactly the same on both monitors, but if I run this very Rec 2100 image through their automated thing, and it makes Rec 1886, then this is what we get.
Wow. Terrible.
See that? It's getting brighter in contrast.
Atrocious.
See that? So they didn't have to do it this way. They could have done it the way I'm doing it, but this is how they did it. And if you're doing that format, like if your distributor demands that you don't do your own HDR to SDR conversion, but you only give them HDR and then Dolby does the automated conversion, this is what's going to happen to it. It's changing all the relative contrast. Now, they do allow you to do a little bit of trim adjustments, but they only let you do simple overall things. You can't actually exactly counteract this shift. So that's another way that we're saying, here's your movie in HDR and here's your movie in SDR, even though the reason these two formats look different, here isn't anything inherent to the format. It's a political thing that we're being forced to convert between the formats using a conversion that does not maintain the relative contrast, even though it's perfectly well possible to do so. And this particular thing can get even weirder. The thing is, these things aren't in isolation. All of these messed up things are happening at the same time. So they're also likely to be looking at it at 100 nits. So now these two are next to each other, and the one on the left looks brighter than the one on the right, but the one on the right is actually brighter in contrast because it's SDR and it can be any brightness.
And the deceptive overall luminance shift is masking the very real relative contrast shift.
So they do let you do trims, but besides the fact that they don't let you trim it perfectly to count, firstly, why would you have to do a trim? I already decided what I wanted it to look like. Why don't you just make it look like that instead of have to redo every shot? But not only that, you might make the wrong decisions on the trim if you've got the brighter contrastier one being fed into a monitor that's dull and dingy, and then you think that it's the image that's dull and dingy because you got the two monitors next to each other. So that's yet another issue with that. Okay, so that's the end of the sub bullet points. So going back to the main ones. The irony of loudly boasting that HDR best transmits filmmakers' intent when so-called SDR is the more reliable system for viewers to see relative contrast is authored by the filmmaker. This is just kind of putting together a bunch of things we already saw, which is at the beginning we saw it's the relative contrast that matters.
And we see what a mess we've got both with HDR as a signal type that's entangling relative contrast and overall luminance right when we need them to be separate.
But also just with the misconceptions driving real decisions. And those two things together make SDR much more reliable to actually know that the audience is going to see the decisions that the filmmaker made. Yet the HDR lobby is loudly boasting, see exactly as the filmmaker intended, when you're much less likely to see the exact relative contrast that they saw when they were making their decisions in an HDR system. Again, partially because of technical realities and partially because of misconceptions that aren't enforced by the technical realities but exist anyway. So for the future, what do we do about this? So we've kind of already talked about this. We can see in the short term, we can do a lot better just by changing our mental model. Once scene white becomes part of how we talk about it and think about it, if we talk to our collaborators at post houses and DITs and everybody in this sort of new language where we understand that HDR is a format to transmit our decisions, it's not something to shackle our decisions, we can make a lot of changes and improvements literally just by changing how we think about it and how we talk about it. In the medium term, we can advocate for some SDR to HDR methods that aren't based on deception and double talk, because in the example here, I'm doing my conversions here and it works great, but I'm building it myself. It's based on the published map, but I do have to build it and have to explain to people what's going on. But we could codify this a little more where even sort of the way that I'm doing it could be in some of these softwares like Nuke, which I'm using here, or Resolve, where we understand what scene white is, how we want to map our images so that they do look the same when the filmmaker wants them to. That's in the medium term. And in the long term, advocate for getting rid of the current HDR style formats and the problematic dichotomy and advocate to completely replace it. Because in that medium term thing, I'm talking about how do we map scene white and stuff. If we got rid of what I believe is a mistaken thing where the color space is nominally absolute when it isn't, if we actually got rid of that and it wasn't even in there, we wouldn't even have to figure out all this scene white stuff and complicated mapping scene whites and all that.
Because instead of having a problematic system with patches on it, we would just get rid of the problem at the root level.
So we could advocate for this new color space, which you could have a fantastic color space. It could be the next upsell gimmick. We don't have to sell it as going backwards. And what it could be, because remember, a color space is just those three things: primaries, white point, and transfer function.
So check it out. This is what we could do. We could go back to a relative instead of absolute y-axis, a gamma style transfer function, doesn't matter which one.
Almost all the white points are the same. There's only one color spacing use as a different one, so the white point kind of doesn't matter. And then for the primaries, what we could do is we could go to wider primaries than Rec 1886, but not so wide as Rec 2020, because that's a waste, because we saw in the real world, efficiency matters, and nobody is going to the edge of Rec 2020. You know, no real world movies are going out here, because in reality, monitors can't even show that. Like this really expensive monitor that we've got here that's top of the line, let me show you its physical primaries. What it can physically do is that. See, it's the one in the middle there, so it can't get to 2020 anyhow. So we're making our image file inefficient, because remember the analogy of we've got a fixed container, there's a bottleneck of the data rate, and we're holding some of it out for numbers that we never use, for colors that we never use. So in this proposed new format, we could have primaries that are wider than Rec 1886, because even though I personally don't use that, I don't want to enforce other people's tastes, but just reasonable instead of crazy. It'd give us a better quality image because of the efficiency. The compression's used better. It would be able to take advantage of what's great about these monitors, including the being able to adapt all the way bright, like for that monitor at LAX that I mentioned, and adapt to different viewing environments coherently, make better use of the data rate, but you still have wider primaries. It gives us everything except one thing, but we can add that on too. The one thing we're missing is punching through the ceiling, but we could do that too. I actually have a proof of concept thing that I've made, and it doesn't have to be this. It could just be something like this. But once you admit that all of that stuff was double talk and really all we're getting is punching through the ceiling, you can do it a different way. Because right now, like I said, we're making our use of our fixed data rate very inefficient by holding out all of these code values that we don't use. But what if we regain them and then we make a thing? So I've made this as a proof of concept, and I call it Scorch, but you could call it Sizzle or whatever we want to call it to make it sound fancy. And I haven't mentioned this before, but That's actually what we've been looking at several times scattered throughout the demo when I'm showing you these highlights punching through the ceiling. so in the real world, when people are doing these punch through the ceiling looks like this, again, I personally don't even do that on my movies, but the people that do,
They can't get that look by just dropping one simple color grade onto the whole movie.
because it just doesn't work on different shots.
Because a one-size-fits-all approach just doesn't work, and you have to build it from scratch shot by shot.
Some shots where the bright part meets the not bright part is a hard edge. In some shots, it's a gradient. And then in some shots, the super bright stuff is neutral, and in others, it's got a lot of color in it or whatever. And usually, if you make a quick color grade that makes that look, it just doesn't work on everything. But I've made this thing that I call Scorch, but again, we can recall it Sizzle or Glint, or I don't know what you want to call it. But I've made this thing,
And it's more complex and R&D than a simple color grade, and I actually have plopped it on everything.
and actually works on everything. It doesn't fall apart. We can put it on everything, and it works for that look. Peaks up the highlights. They really are getting 3.5 times brighter. It doesn't crush or clip information. Like in this shot, it has exactly what people sort of imagine, where without clipping any of the information that the camera got, it pulls out the details in the fire, and it really works on everything. And the thing is, even though I'm saying it's just an algorithm that works on everything, you don't have to build it shot to shot. That doesn't mean everybody's movie has to look the same. Because firstly, it's not just on and off. You can put it at any level from 0 to 100%. That firstly, but secondly, you are going to color grade the movie. So if somebody wants this, again, I personally probably wouldn't use this on my movies, but obviously people want this because there's a lot of movies doing it. You could use this thing in the color grade, because what the Scorch is doing is it's taking the brightest stuff and pushing it up. So in the grade, you can ride that. You know, you could take something and push it into Scorch some more, or pull it out of Scorch, and you can do your own thing on the movie. And what's great about this is if we go from 8-bit to 10-bit, which is what you need, we say you need 8-bit to 10-bit just to be able to punch through the ceiling. That's 8 million bits per frame. This is 8 bits per frame, or potentially 8 bits for the entire movie. You just say this is a 100% Scorch movie, or this is a 50% Scorch movie. So with that, we could reclaim the best of everything, the best of the SDR signal, the best of the HDR signal. You can still punch through the ceiling. You have your wider color gamut. We're not sacrificing efficiency, and you can advertise it as the new super diddly duper vision, or whatever it needs to be called to sound like something fancy. And it really would have a new thing to it. People make TVs, discs, streaming services, set-top boxes, handheld devices. All these people that want to upsell, this could be their next one after HDR.
And the advertised benefit of an upgrade would actually be a real thing and not snake oil, because current TVs and other devices aren't set up to send and receive Scorch signals. That's just not in the current specification. So it could be the best of all worlds.
So with that said, I'm just going to do a 2-part recap. And the first is this checklist. This is a list. I'm sure there's things I didn't think of, or maybe I've turned one thing into two here. I don't know. But this is sort of a checklist of different attributes that are either actually or perceived as positive in image rendering that have to do with HDR. So we can see all of the positive things. HDR is the only one that has negative check marks, except for that one trade-off of punching through the ceiling versus being able to use the monitor's brightness to adapt to the environment. So just to go through them real quick, can show full black if monitor is capable. Yep. Descend to 0 and you get full black. That's not different between SDR and HDR. That's a difference between a good monitor and a bad monitor. If monitor can't show black, that's a junky monitor, but that's not an attribute of the signal type, the color space. Can reproduce subtler increments of luma at any given bit depth. We saw that HDR needs 10 bits to be as good as SDR at 8-bit. Whenever you do apples to apples, all of the increments are coarser on HDR than SDR, because it's not only going way above scene white, it's going way above any peak white that we could possibly use. We can reproduce subtler increments of chroma at any given bit depth. Same exact thing with luminance is the same for chroma. We've got this super wide gamut and we can't use the edges of it, so you're just holding out space and all of the increments are coarser. Faithful reproduction of relative contrast is authored by the filmmakers if the monitor is capable of it. We saw SDR is much more reliable than HDR in current implementations. Luma is relative, not absolute, so it works like the human visual system, motion picture film, and visual arts that are reflective instead of emissive, like painting and printed photography. Yes, absolutely, because even motion picture film is like that. When you shine light through it, the film blocks out a percentage of whatever light you send through it. The film doesn't emit a fixed amount of light. Contrast in Luma reproduction obeys the published specification, i.e. the color space transfer function, through the entire Luma range when using a well-calibrated real-world monitor. Yes, SDR does that. HDR needs all kinds of patches on it to explain what to do if you're asking for things that are too bright or too dark or to adapt to the environment or whatever. We're just diverging from the spec anyway, so why do we even have the spec? Skin tones and other near neutral colors are not limited in saturation, vibrance, or richness. We saw we can go absolutely obscenely garish with skin tones, even in the narrowest color gamut. Extremely saturated colors like neon signs, car brake lights, and lasers can be displayed either with traditional artful color rendering or with electronic garishness as preferred by the filmmaker. We can already make things too garish, as we saw we had to pull back for my taste. But what if you want to go even beyond that? What about super extra duper garish? Well, they can still both do that, but we would need to actually implement Rec 2020 or something for SDR to do that. So just at the moment, it's harder to do that in SDR, but that's not a real differentiation. Can display highlights either gently and artfully or more caustically as preferred by the filmmaker. We saw we can do a caustic look in traditional SDR, just not necessarily that exact punch through the ceiling one. We can do gentle highlights or sizzly highlights. So SDR can do either. HDR can also do either, but because of all the confusion and chaos, there's a perception that you have to do the sizzly ones. So it's actually limited by politics, even though it's not limited technically. But what if you want even more sizzly poppy highlights than that? You can already do pretty sizzly poppy ones that are a lot compared to a traditional cinema. But what if you want to go even further? That is one that SDR currently can't do, but SDR type thing could do it if we added that scorch or sizzle thing that I mentioned, and then this would become a green check. But for HDR to do that, it's a trade-off where overall luminance, not just little areas of the frame, can take full advantage of the monitor's maximum brightness. And we saw that. And this one's also ironic because people talk as though HDR is brighter, but SDR can actually be brighter on any given monitor because you can put scene white all the way up to the max that the monitor can do. Whereas with HDR, you have to have an artificial ceiling so that you can punch through it. So you actually can't put scene white at the max. So that's the checklist part of the recap. And then we'll just do this one last bit, three-part recap. 1. HDR quality hardware advances are great and nothing but a boon to imaging. The complaint is with the so-called HDR signal types, the color spaces, that we're using to drive that hardware, and with the fact that deep misconceptions are major influences on real-world decision-making. When it comes to formats, i.e. color spaces, as opposed to hardware, with the exception of one thing, how we use the excessive screen brightness available, which is a trade-off more than an advantage, the things that are actually different about HDR compared to SDR are all detriments, not advantages, and they're only dressed up as advantages by misinformation. And finally, we can do a lot to overcome the problems just by changing our mental model to align with reality instead of with common fallacies. But even that last little bit that can't be done just by changing our approach and could get us all the way to all of the advantages of both the hardware and the bandwidths and everything, and get rid of all of the detriments. And even that last one little thing is not a big technical hurdle and would only be a small change to current SDR style color spaces. But it could be marketed as the next big thing. Again, we can call it ultra double, extra high vision, or whatever we need to call it so that it sounds good and it becomes an upsell gimmick. Yeah, I'm just advocating in the future, let's make that next color space an actual improvement, not just an improvement in name. And I just want to say before signing off that even if superficially some of this demo has been negative, its deeper essence is meant to be inspiring and empowering. All it takes is a little shift in our mental model and some effort to see past the misconceptions, and there are exciting possibilities for more freeing image authorship for filmmakers, more fidelity and beauty in images for viewers, for a deeper yet more straightforward understanding of how imaging works, and hope for future color space standardization that could capture all the current benefits and more, with none of the detriments. Thanks for watching.
Jesus Christ. Good job, guys. Wow. Do you guys feel informed? I feel informed. I feel like I learned so much. Summarize? I can't. If you didn't get it, you didn't get it. If you didn't get it, you didn't get it, and you'll never get it. If you didn't get it, you didn't get it, and you won't get it. Gone over the Tulsi Gabbard stuff? No. I will tomorrow though, okay? It'll be so much fun.
Terminator 2 and that it came out. Did you know they did a remake of Terminator 2 and that it came out this year and made $200 million? If you didn't realize it, it's because they called the film One Battle After Another. I'm not joking, and in fact, I thought everybody knew this. I mean, it's not a secret. The cast talked about it in interviews. There's a famous interview where Paul Thomas Anderson talked about how Terminator 2 was one of the films that inspired him to do what he does. Or specifically the fact that some people don't treat Terminator 2 as a great piece of filmmaking, which he does. And I think the people involved in making the film would say that it's just an homage, but it's pretty much Terminator 2 top to bottom. Let's walk through it. Both films start with an aging, kind of burned out revolutionary. Of course, in Terminator 2, that's Sarah Connor, played by Linda Hamilton. In One Battle After Another, that's Bob, played by Leo DiCaprio. Both films are structured around a series of chase scenes in which the goal is to try to protect the child of the revolutionary. Of course, that's John Connor in Terminator 2. In this film, it's Willa. Note the jacket, which is clearly a little nod to the black biker jacket worn by Arnold in Terminator 2.
Okay, this is retarded. Okay. I'm going to go to sleep. Tomorrow we're going to have a normal stream. I'm going to wake up. It's going to be great. I missed yesterday's connection. Is there a way to go back to do yesterday's connection? This? And we did that one. Uh-oh.
I have both up at the moment. I just mute one or the other. Nice. Okay, good. That's the right thing to do. That's the appropriate thing to do. That's the real Hasanabe head method right here. Anyway, yeah, open it on both. Just pump it. You know what I mean? Just pump it. Go crazy with it. Go crazy with it.
Uh-oh. Isn't that illegal? Okay. I'll be back tomorrow. Stay safe. Be careful. Don't die. I love you. Good night.